All right, so let's talk about route filtering techniques. So in this topology, we already have all the prefixes. We can confirm that if we have all the prefixes or not. So maybe I can go on router number 3, let's say. And on router number 3, we can check if we have all the prefixes or not. So let's go on router number 3. And this is OSPF, like we are running OSPF here. We can confirm show IP route OSPF that we have some inter-area prefixes, we have some intra-area prefixes. Apart from that, we have some external prefixes as well. So we must see that external type 2 prefixes are there. So we are receiving like quite a lot of prefixes. Okay, I'm not receiving 130 subnets. Let me cross check why we are not receiving 130 prefixes. So show run pipe section router OSPF. Redistribute rip metric 1, that is fine. Show IP OSPF database, NSS external. Yes, LSAs are there. Then why we are not having the type 2 LSAs for 130 subnets? Let me check. So 120 is there, 130 is not there. Okay, show IP OSPF database. Okay. Oh, sorry. So here we are not receiving the prefixes. I observed that we are not receiving the prefixes here. We are not receiving these 130 prefixes here, or anywhere. So when I checked the configuration on router number 8, I found out that here we are using a command called no redistribution. That means on that router, the redistribution will not take place. So actually we need to remove that command so that we receive the rest of the prefixes. So when we remove that command, we should see the external prefixes. We should see that we are receiving those 130 subnets as well. Yes, now it's okay. So we are receiving like 120 prefixes, we are receiving 130 prefixes, we are receiving like other inter-area, intra-area prefixes. So now we need to use variety of route filtering techniques to perform route filtering in this scenario. Here in this topology, we are running protocols such as OSPF, we are running protocols such as EIGRP, we are running protocols such as RIP. So we will be able to perform the route distribution in like all these protocols. Although we don't need to worry about the RIP routing protocol, so we'll focus very little on the RIP routing protocol. We'll focus more on the OSPF and EIGRP from the route filtering point of view. Okay, so what I'm going to do here, I'm going to add one more cable between router number 11 and router number 12. And that is going to be FA 0 by 1. I have added one more cable there. And I'm going to add one more cable here as well. So this is going to be under the router 8 and router 13. So I have added like one more cable here as well. So we have added like multiple cables between router number 8 and 13. And we have added multiple cables between router 11 and 12. Why? Because we want to receive the same routes on multiple links so that we can either select one link over the another link, or we can filter the routes from one link over the other link. So I'm just going to configure the IP addresses on there. So configure terminal FA 0 by 1, IP address is going to be whatever, like 100.1.1.12, does not matter, no shut. And since we configured EIGRP network 000, do show run pipe section router EIGRP. Since we configure network 000, as soon as we configure this new link, the EIGRP will get enabled there automatically. So we no need to enable it because network 000 command is running. We will go to router 11, configure terminal, router interface FA 0 by 1, IP address 100.1.1.11, 255.255.255.0, no shut, router EIGRP. network 100.1.1.0 I have configured. So now in between these two devices like router 11 and router 12, EIGRP is enabled on FA0x1 interface and EIGRP is enabled on FA0x0 interface. And both of these interfaces are practically identical. Like this is the fast Ethernet, this is the fast Ethernet, same bandwidth, load, delay, reliability, MTU. Every configuration is going to remain the same. And that is why if you go to router number 12, you should see that show IP route EIGRP. You should see that in EIGRP, we are receiving all the same prefixes from multiple links. We are receiving them from 112 and we are receiving them from 100. So all the prefixes on router number 12, we are receiving from multiple links like this link and this link. And now we might want to perform some sort of filtering. We want to prefer one link over another link. We want to do some sort of route filtering that can be done now. Same thing, I will go on router number 8 and router number 13 as well. In between router 8 and 13, router 8 and 13, I have added one more cable. So configure terminal, interface, IP address, whatever you want to configure, you can configure it. And here also, since we have used do show run 5-section router RIP, here also, since we have used network 0000, so RIP gets enabled onto that interface automatically. So I just need to configure the IP address there. The router 13 FA0x0 configured with the IP address, and I will go to router 8 as well. On router 8, configure terminal, interface, FA0x1, IP address 200.1.1. It is 8.255.255.255.0 and router RIP and network 200.1.1.0. So I have added one more link between router 8 and 13, configured it with some IP address. The IP address that I have given here is 200.1.1.subnet. And once we have configured the IP address, I can confirm that I can go to router number 13 and all the routes that we were receiving earlier only from one path. Now we are receiving those prefixes from multiple paths. RIP sends the update in every 30 seconds. So you might need to wait a little bit before you receive the update. Once it has been 30 seconds, you will receive those updates from multiple paths. So you just need to wait. So just like, for example, here, we have received one prefix from multiple path, you will receive the rest of the prefixes from multiple path as well. And as you can see, RIP takes quite a lot of time. Like some prefixes are coming from one path, some prefixes are not coming. So RIP takes quite a lot of time. So you have to be patient. You have to have some patience. So like now you can see that here, now we are receiving the prefixes from both the path. RIP converts very slowly. So RIP takes some time in convergence and also. Okay. Why I'm not receiving 120 subnets? Let me cross check that as well. Oh, 120 subnets we will not receive because we have configured this area as NSSA. So since it is configured as NSSA, these prefixes will not be allowed to go here. Right, but since we have the default route will be advertised here, and following the default route, the reachability can be ensured. On router 5, on router 6, we have used the either default information originate command, or we have configured totally NSSA, where the router generates the default route automatically. So this device is going to advertise the route anyway. So anyway, we have the reachability end to end, and now we have all the routes end to end, and now we can perform route filtering on these devices. So let's say, for example, when it comes to route filtering, we have quite a lot of ways that we can use to perform the route filtering between the devices. The easiest way to perform, we are talking about route filtering, and maybe like I want to prefer one path over the another path, like primary, secondary. Maybe we don't want to filter the route. Maybe we do not want to filter the route. We just want to configure one route as one path as our primary path and the second path as the secondary path. So not necessarily that you have to filter all the routes. So route filtering, however, route filtering basically means we are going to filter all the routes, but not necessarily you need to filter. You can also, like, for example, choose one path as the best path and the other paths as the backup path. So route filtering and path manipulation, basically we are talking about in case of IGP protocol, how we can influence the best path selection in case of IGP protocol. So the easiest way to perform the route filtering, is going to be the AD value. By using the AD value, administrative distance value, the easiest way to perform the route filtering is that the easiest way to perform the route filtering is that we can use the AD value. We can set the AD value to 255 to perform the route filtering. This is the easiest way to perform the route filtering. So what I want to do, I want to filter all the prefixes. I can filter all the prefixes by setting the administrative distance value to 255. So, okay. So for example, in this topology on router number 11, I do not want to receive any of the EIGRP prefixes. I do not want to receive any of the EIGRP prefixes. So I can go on there on router number 11 or maybe on router number 12, whatever, doesn't matter. You can just say, I want to filter all the prefixes. I do not want to receive any prefixes from EIGRP. I do not want to receive all these prefixes from EIGRP. So what you can do, you can say router EIGRP 100 and you can use the command distance EIGRP and you can set the administrative distance value for internal route and you can set the administrative distance value for external route. Basically, by executing this command, what we have done, you have set the administrative distance value to 255 for internal route. You have set the administrative distance value to 55 for external route. All right, so distance EIGRP, AD for internal route, AD for external route. So you change the AD value to 55 for internal and external. As a result, you can confirm that you do not have any route in your routing table. So as simple as this, we can filter the routes with the help of the AD value. Similar thing you can do in the OSPF, like you can use the commands in OSPF routing protocol as well. Similar set of commands, such as, for example, you can go to router number 3, configure terminal, router OSPF, distance, OSPF, then AD for external route, AD for inter-area route, and AD for intra-area route. We can configure to 255. Once we configure the administrative distance value to 255, those routes are going to be filtered. So distance OSPF external, this inter-area, intra-area, I have set all the administrative distance value to 255 and do show IP route OSPF. You can see that routes are no longer there. Same thing you could have done on the RIP routing protocol. Maybe you can go to router number 13, configure terminal, router RIP, same command, distance. Here you can configure the AD value to 255 just simply. Distance 255. This command is going to change the AD value to 255 for all the RIP prefixes. Now remember, in the RIP routing protocol, it takes some time. So once you set the administrative distance value to 255, you might not see the convergence right away. You might not see that the routes are getting filtered right away. So do show IP route RIP. You can see that the routes are still there, but these are invalid now. Because in RIP, the timer is like the RIP sends periodic update in every 30 seconds. And since the timer has gone beyond 30 seconds, it means that these routes will be filtered. But in RIP routing protocol, it could take up to 4 minutes to perform the filtering or any changes. In RIP routing protocol, changes could take approximately 4 minutes, like 240 seconds in total for convergence and all. So forget about it. You want to check it. You want to filter the prefixes right away. Just use the command clear IP route star. This command is going to clear the routing table completely. And now this router is going to wait to receive the route from the neighbor router. So this command is going to clear the routing table. This command means clear all the routes from the routing table. Star means all. So clear IP route star means clear entire routes, all the routes from the routing table. And now if you check show IP route RIP, you don't see any route because routes have been filtered. So in every protocol, we have this command distance. Using the distance command, we can use the route filtering. We can filter the routes based on our requirement. Right, we can just go under the router EIGRP, that is 100, and use the command like no distance or distance, whatever command we have used. You can just negate that command so that the routes again gets installed in the routing table. Otherwise, like if you set the AD value to 255, the route is going to be filtered. A route with the AD value of 255 never gets installed in the routing table. One thing to keep in mind about this AD value, any sort of route filtering that we perform in OSPF routing protocol. One thing you must keep in mind about any route filtering technique that you do in OSPF routing protocol. One thing you must understand that in case of OSPF routing protocol, let's say I went on router number 3, I said that I want to filter all the prefixes. And to do that, what I have done, I have changed the AD value. And the same thing, what I'm going to do, I'm going to do the same thing on router number 4 as well. Here, like configure terminal. And here also, I'm going to use the same command. Basically, on router 3 and router 4, on these two routers, I have set the administrative distance value to 255 for all the prefixes. That means on router number 3, do show IP route OSPF, and on router number 4, do show IP route OSPF. On both the routers, we do not have the OSPF routes. But remember, like if you go to router number 5, maybe, let's go to router number 5, maybe, go to router number 7, maybe, like you go to router number 7, maybe, and here you check show IP route OSPF, you are receiving all the prefixes. You are receiving like 9.9.9 prefixes, which is router 9 prefixes. You are receiving like 5.5 prefixes, 4. We are receiving all the prefixes actually. So prefixes are not available on router 3, prefixes are not available on router 4, but the prefixes are available on router 5, router 6, router 7, router 8. These prefixes are available on router 1, router 2, router 9, router 10, router 11. Those are there. We do not have routes here, but we have the routes here and we have the routes here. And why is that? Because when we talk about the route filtering in protocols such as OSPF, the command that we have just executed is going to filter the routes, but this command cannot filter the LSAs. So this router has advertised the LSA to router number 3. Router 3 has advertised that LSA to the neighbor devices. Router 5 has advertised the LSA to the neighbor devices. And because these routers are still receiving the LSAs, they can calculate the route. So the point is that in case of protocols such as OSPF, OSPF is going to, like route filtering techniques are going to filter the routes. Route filtering techniques such as distance, such as ACL, such as prefix list, whatever, they are going to filter the routes. However, in OSPF, we exchange the information in the format of LSAs. So route got filtered, that is okay, but LSAs got exchanged. So the routes are available here. Of course, you will not be able to ping from here to here because these routers, they don't have the route. But again, in OSPF protocol, it is completely possible that these routers, they don't have the route, but these routers, they have the route. Because route filtering techniques filter the routes and OSPF exchanges the LSAs. And since OSPF exchanges the LSAs can be available. LSAs are in fact available on all these routers. As a result, these routes are available here and these routes are available still here. You will not be able to ping because these routers are not having the routes. Right, so this is not possible in the distance vector protocol such as EIGRP. If with the help of EIGRP, I perform the route filtering on router 3 and router 4, those routes will not be available on router 5, 6, 7, 8 because EIGRP can only advertise the best route information to the neighbor router. And since the router itself is not having any route as the best route to reach to the destination, it cannot advertise it to the neighbor router. So yeah, in case of protocols such as OSPF, it is completely possible that some routers don't have the route, but some routers have the route because the way OSPF exchanges the information. This is it. This is how we can we can filter the prefixes with the help of the AD value. Now, the problem in this approach is that we are not able to select what route we want to filter. This command is just going to filter all the prefixes, all the external prefixes, all the inter-area prefixes, all the intra-area prefixes. This command is just going to filter all the prefixes. We cannot select like what prefixes we want to filter, from where we want to do the filtering. For example, maybe I do not want to filter the prefixes on both the link. I want to filter the prefixes only on this link. I want that this router must not receive any prefixes on FA0/0, but it must receive all the prefixes on FA0/1. The command that we just executed is not going to help you in that. This command is just going to filter the prefixes. This command is just going to filter all the prefixes, in short. So we do have the options for the same. In OSPF, in EIGRP, in protocols such as RIP, it is possible that we can filter the prefixes from one particular source. Like when I receive the prefix from this particular source IP, then I am going to filter it only. If I'm receiving the prefixes from this source IP, then I'm going to filter it only. If I'm receiving the prefixes from this source IP, I am going to allow it. It is possible in protocols such as RIP, it is possible in protocols such as EIGRP, OSPF that we can filter the prefixes based on the source. Like for example, router RIP, I can see that do show IP route RIP. I can see that I am receiving the prefixes on both of the interface, FA0/1, FA0/0. I can confirm it from here. And when I'm receiving the prefixes from FA0/0, what is the source of that particular update message? 200.1.1.8. This is the source of that update message. And when I am receiving the prefixes on FA0/0, on FA0/1, this is the source of the update message. On FA0/0, this is the source of the update message. I do not want to receive any prefixes from here. So I can just use the command distance to 55 and then I can specify the source address. I can specify that I do not want to receive any prefixes from here. And we need to specify this thing called wildcard mask like 0000, which just tells the operating system, which just tells the iOS that you have to match exactly this IP address. When the routing update comes, when the routing update is received on router number 13, when the routing update is received on the router number 13, if that routing update has the source IP address of 130.1.1.8 exactly, then you need to set the AD value to 255 for those prefixes. So distance to 55, and here we can mention the source. This command we can use to mention the source. Same thing we can do on here as well, on router 11 as well. Instead of using the command distance, EIGRP, don't use this command. Use command distance to 55 and use the source. Like on the router number 11, I am receiving all the EIGRP prefixes from 100 as well as 112. Maybe I want to filter all those prefixes from here. So I can use the command distance like 255 and then this and the wildcard mask. So this means like I'm telling the EIGRP router that when you receive any prefix, any routing update, if you receive the update message and that update message has the source IP of this one, you do not need to accept it. You need to set the administrative distance value to 255 for all the routes that you have received from this specific source. As a result, if you check do show IP route EIGRP, you can check that we no longer are receiving the prefixes from two paths. We are just receiving the prefixes from one path. Earlier, we were receiving the prefixes from both of the paths. But now, since we did route filtering from this particular path, I do not want to receive any prefix from that particular path. So I am no longer receiving the prefixes from that path. I am receiving the prefixes from one path only, FA0/1. Remember that this command only works in EIGRP. This command only works on internal prefixes. This command does not work on external prefixes. This command will not work in EIGRP for external prefixes. You cannot execute this command for external prefixes. Means if I go to router number 12, on router number 12, we are receiving all these prefixes from both of the path. We are receiving all these prefixes from both of the paths. And if I try to do this router EIGRP 100, then distance to 55, and I try to filter it from one of the path, maybe from here, I can see, let this information get resynced. This command that we have executed here, distance to 55, 100.1.1.11, that I want to set the AD value to 255 for all the prefixes that I have received from this particular source. So I saw that on router 11, it did the route filtering, it did filter the prefixes. But if I go to router number 12, do show IP route EIGRP, I can confirm that the prefixes are not getting filtered. I have executed the correct command, but the prefixes are not getting filtered because this command actually works only and only for the internal prefixes. It does not work on the prefixes that got redistributed into the EIGRP. And since all the prefixes that I am receiving on router number 12, all these prefixes are redistributed into EIGRP, that command is not working for them. So the command that we just executed is going to be run. It will run only for internal prefixes in EIGRP. Right. So do show history. This command will not work for external prefixes in EIGRP. This command will only work for internal prefixes in EIGRP. You can check that once we execute that command, you can check that you no longer have the routes from both of the path, but you have the routes only from one path. So we can do the route filtering as per our requirement. We can do the route filtering as per our requirement. You can see that. Like we can filter that if the updates are received from one specific source, I'm going to filter them. So we can also mention the source of the update message. We can mention the source of the update message. Once we have mentioned the source of the update message, the router is going to perform the route filtering based on that source IP. So when the update is received on FA0x1 interface, then it will have the source IP of 138.1.1.8, and as a result, that will be filtered. Okay. Still, now if you want to do the same on router OSPF, you can do it by yourself. You can go to router number. You can go to router number 3. You can go to router number 4 and do the same in router OSPF by yourself. No, a route with the AD value of 255 will never get installed in the routing table, no matter if that is the only path available. So no, if the primary path goes down, the path with the AD value of 255 will not be installed in the routing table. That is why, like, you might not want to do the filtering. Instead of doing the filtering, you could have done this. Instead of doing the filtering, what you could have done this, you could have done this. Like maybe we want to configure this path as the primary path, and since we don't want the route to be sent, we don't want the traffic to be sent from this other path. So instead of doing the route filtering, what we could have done router rip, and we could have said like distance. Instead of setting to 255, I could have set like maybe 200, not the 255. So do clear IP route star. So now what we have done, instead of setting the administrative distance value of 255, I set the AD value of 200. I have set the AD value of 200, which means like when the prefixes are received onto this particular interface, the AD value will be 200. And when the prefixes are received onto this particular interface, the administrative distance value is going to be 120 because of RIP. So now if you check the routing table, do show IP route RIP, you can check that the router has installed the path FA0x1, FA0x1, FA0x1. The router has installed the path that has the lower AD value 120. That router has installed the path with a lower AD value. That is completely fine. But if that link goes down due to some reason, let's say, for example, the interface FA0x1 goes down due to some reason. If this interface goes down, the other path will come into the picture now. Do show IP route RIP, and the other path gets installed in the routing table that had the higher AD value. Just like we did in static routing, we could have like instead of setting the AD value to 255, we could have set the AD value to something other than 255 so that we can have some sort of primary secondary concept as well. Right. So your choice if you want to filter or you want to do path manipulation. You want to prefer one like primary secondary. If you want to do, you can do primary secondary, completely up to you. Otherwise, you can filter the second path completely. Maybe you don't want to receive the prefixes from one path, so you can just filter it. Otherwise, you can basically set the AD value to higher AD value from the other path so that that path is only chosen when the primary path goes down. So primary secondary game you can also do here, just like you did in static routing. So primary secondary we can do here as well. Now, still, we have not specified what prefixes. We said that all the prefixes that you receive from here, set the AD value, set the administrative distance value to 200. I still did not specify what prefixes. I said like this command is going to say, this command is going to tell the operating system, this command is going to tell the router number 13 that you had to set the value to 200 for all the prefixes that you receive from this particular source. We still have not defined what prefixes. We still have not defined here what prefixes. We still have not defined which prefixes like I want to influence. This command distance to 55 is going to set the AD to 255 for the prefixes. We can also do it from a specific source, that is fine. But I also want to have the AD getting changed for specific routes. I don't want to change the AD for all the prefixes. I do not want to change the AD value for all the prefixes. I want that this may be router number 11, maybe show IP route EIGRP. What I want that I want only and only for these three prefixes. I want that only these three prefixes. I want to change the administrative distance value only for these three prefixes. I want to change the AD value for only and only for these three prefixes. So what we can do, configure terminal, router EIGRP, distance, either you can set it 255, whatever you want to set, 200, whatever you want to set, completely your choice, distance 200. And then from where, when the prefixes are received from this particular source, okay. And just after that, we can also tell this operating system, we can also tell this router 11 that when we receive certain prefixes from this source, not all the prefixes, when we receive these prefixes from this source, then only set the AD value to 255. And that, like what prefixes I want to change the AD value for, that thing can be specified just after that by using this concept called ACL. We can configure here an ACL. We can write down here with an ACL number or name that I want to change the AD value to 200 when I receive these prefixes from this particular source, such as, for example, 50. And now I'm going to create an access list 50, and what prefixes? Permit the prefixes 120.1 prefix. Okay, this is one prefix, this is second prefix, and this is third prefix. So I configured an access control list. In that access control list, I matched 120.1.1.0, 120.1.2.0, 120.1.3.0/24/24/24. I have matched the prefixes in our ACL, and I have referenced that ACL right here. I have called that ACL right here. So I said EIGRP, I asked the EIGRP to change the AD value to 200 for these prefixes when they are received only from here. And you check it now, do show IP route EIGRP. You can see that the AD got changed for this subnet. I can also do like clear IP EIGRP neighbor ones so that the prefixes get received again. Let's check it again. So now you can see that these three prefixes, only for these three prefixes, 1, 2, and 3, only for these three prefixes, you can notice that only for these three prefixes, AD got changed from the other path, from this path. But for the 4.4 and 5.5, for 4.0, 5.0, the AD is exactly the same as it was earlier from both the paths. So we can also mention just after that an ACL. In that ACL, we can match our desired prefixes for which we want to perform the path manipulation, or maybe we want to filter. If you want to filter, set the AD to 255. If you want to have primary, secondary, set the AD value to other than 255. Right. So access list 50 permit, and then configure an ACL. In that ACL, match your desired prefixes, and then use the AD command, then use the distance command for the same. Same thing you can do in RIP. you can go to router number 13, and just after that, just after this command, you can also mention here the AD value, the ACL, do it yourself. You can go on router number, maybe OSPF, maybe router number 3, and distance, like I can say 100, and then we can specify the source, maybe 5.5.5, and then we can specify the AD here as well. Sorry, ACL here as well. So same set of commands. We have 3 commands now in total. We have the command, simple command distance. Then we have command distance plus we have like distance plus source, and we have command like distance plus source and plus ACL. So whichever is required as per your requirement, you can use either this one, or you can use this one, or you can use this one completely. Okay. Now remember that in case of OSPF, since OSPF exchanges the LSAs, remember that in OSPF routing protocol, when we want to mention the source of the update message, remember that OSPF routing protocol actually exchanges the information in the format of LSAs, and LSAs have the OSPF router ID as the source ID. So source in case of OSPF should be the router ID of the router from where the LSA is being received, like advertising router ID. In case of OSPF, here we cannot specify the IP address. Here we need to specify the router ID. Because in OSPF, the information is exchanged in the format of LSAs. In OSPF, information is exchanged in the format of LSAs, and LSAs have that field called advertising router ID. So you need to mention that when you receive the prefixes from 1.1.1.1, or when you receive the prefixes from 2.2.2.2, then only you need to perform the filtering. So in case of OSPF, in case of open shortest path first, instead of configuring, instead of specifying the IP address, we need to specify the source router ID. Because in OSPF, the information is exchanged in the format of LSAs, and LSAs have the advertising router ID. So in case of OSPF, instead of defining, in case of OSPF, instead of configuring, instead of defining the source IP address, we need to specify the router ID of the router from where the LSA is being received. This is how we can use the administrative distance value AD to either filter the prefixes or influence the prefixes as per our requirement. If you set the AD value to 255, it will filter the prefixes. Otherwise, if you set the AD value to other than 255, less than 255, whatever AD value you have set, then the prefix is not going to be filtered. It is like manipulation you have done, like best path, backup path, or primary, secondary. You have done. Okay, done. Any doubts if you have, you can let me know. This is AD, administrative distance. Okay. Now, let's say they have asked us not to use the AD value. So maybe we are not allowed to change the AD value. So we are not going to use the AD value. Let's say that we are not allowed to change the administrative distance value. So we are not changing the AD value. We are not changing the AD value. So AD value is set to whatever it was earlier. We have not changed the AD value. So that is fine. The second option that we have, remember that with the help of the AD value, we can do two things. We can either filter the prefixes or we can influence the prefixes as per the requirement. But when it comes to like the second option where we have the ACL, we can configure the access list. We can configure the ACL. We can use the access control list to filter the prefixes as well. ACL, access control list, can not only be used for the traffic filtering. ACL, access control list, can be used for traffic filtering, and ACL can be used for data filtering, and ACL can also be used for route filtering. ACL can be used for traffic filtering, and ACL can be used for route filtering as well. ACL can be used in other places as well, such as we can use the access control list under the line VTY, so that we can control who can telnet, who can SSH. That thing can also be done. A lot of places ACL can be used. When we configure the ACL for data filtering, we configure it under the interfaces. When we configure the ACL to control who can telnet SSH, we can configure it under the VTY lines. And when we need to configure, we need to perform the route filtering for route filtering. When we need to use the ACL to perform the route filtering, we need to apply it under the routing protocol. When we need to filter the prefixes, using the access control list, we need to apply the ACL under the routing protocol. Now, as you must know, ACLs are of two types. We have two types of ACL. We have a standard ACL. We have a extended ACL. We can use both of the ACLs to perform the route filtering. However, most common type of ACL that we use to perform the route filtering is the standard ACL, and most common type of ACL that we use to perform the data filtering is like the extended ACL. Because extended ACL gives us way too much options to perform the filtering based on different criteria. So very popular technique to perform the data filtering, and the standard ACL is very commonly used to perform the route filtering, but both can be used for both of the tasks. We can use the standard and extended ACL to perform the data and route filtering as well. You must know already that when it comes to the standard ACL, the only criteria that we can use to match the prefixes is the source IP. But when it comes to the extended ACL, we have like a lot of options based on which I can match the packet. So we have the source IP, destination IP, source port, destination port, protocol number, protocol name, different types of things are there. So let's say we want to filter the prefixes. We want to perform the route filtering. Remember that with the help of the ACL, we cannot actually do the route, we cannot influence the route. It will just be filtered. We cannot like influence that, okay, this is primary, this is secondary. We cannot do that with the help of ACL. It will just filter. So when we are using the standard ACL, to perform the route filtering, how we are going to use it? A standard access control list to perform the route filtering. Remember that a standard access control list can be created by number, or a standard access control list can be created by name. There are two approaches that we can configure: the standard or extended ACL, numbered approach, named approach. These are some things from your CCIE studies, and also numbered ACL, named ACL, and all that. So let's see how we can use the standard access control list to filter the routes. Let's say, for example, on router number 3, I want to receive only and only 120 prefixes, and I want to receive only and only 130 prefixes. Rest I want to filter. On router number 3, I want to only and only receive these prefixes, and rest of the prefixes I do not want to receive. Rest everything like I want to deny. The task is to filter the prefixes on router number 3, and you should only receive 120 and 130 prefixes. Rest you have to deny. So when we configure the access control list on router number 3, how we do this? We go to router number 3, we use the keyword access list, and we specify the number of the ACL. If we specify the number 1 to 99, it will be the standard ACL. Or if we specify the number 1300 to 1999, it will also be the standard ACL. It is the expanded range for the same. We can choose any number such as 50. And here we need to specify permit. Permit means match, allow. I want to allow these prefixes. Whatever prefixes you want to allow, you permit them in the ACL. Whatever prefixes you don't want to allow, deny them in the access control list directly. Remember that we are going to use this ACL directly to perform the route filtering. I am not going to use this ACL in the AD value. I am going to use this ACL directly to perform the route filtering. So in the ACL, whatever you want to allow, permit it. Whatever you want to deny, deny it. So access list 50 permit. And what do you want to permit? Exactly what do you want to permit? Here you have to write down a network ID and subnet mask in such a way that matches the desired range. Here you have to write down a network ID and a wildcard mask in such a way that it matches 120.1.0.0 to 120.1.5.0 and 130.1.0.0 to 130.1.5.0. You have to write down an access control list, network ID and wildcard mask in such a way that it matches the prefixes from this range. So we can use the access control list, we can use the ACL, we can use the standard ACL, either named or number. Remember that the standard ACL can only do the filtering based on the source. So in the source IP, when we write down the ACL, access list deny, and here we specify what prefixes we want to allow or what prefixes we want to filter. So in the source, we specify like what prefixes we have to filter, what prefixes we want to allow, what prefixes we want to not allow. For example, let's say we want to filter the prefixes from this range to this range, like 7.7.0.0 to 7.7.7.255. Let's say we want to filter the prefixes from this range. I do not want to receive any prefix from this range. So I have to write down a network ID and wildcard mask in such a way. I have to write down a network ID and wildcard mask in such a way that it matches and filters all the prefixes from this range. How that can be done? To do that, just to revise all your ACL concepts from your previous studies, what you need to do, what we do actually, we write down this range into binary. We are going to see 7.7.0.0, 1, 2, 3, 4, 5, 6, 7. I'm going to write down these addresses into like this, and then I'm going to write down the binary of that. Basically, what we need to find out, that if we want to match all these prefixes, if we want to match all this range, if we want to match this range, then what network ID should I write? If I want to match all these prefixes, what in the access list 1, what network ID should I have to enter? So we need to find out the network ID that can represent all of these prefixes. Basically, we need to find out the part that is common. We need to find out the part that is common in all these prefixes, because the common part in a range is what we refer to as the network ID. By the definition, what is the network ID? Network ID is the IP address where host part is completely zero. Network ID, by the definition, is an IP address where the host part is completely zero. In a set of prefixes, network ID is the part that is common. Network ID is the part that is common in all the prefixes. Network part in this range, the network part is the part that is common in all these prefixes. Whatever bits, whatever number of bits are common in all these prefixes, we have to consider that part as the network part, and remaining part that is changing, we need to consider it as the host part. And to write down the network ID, we have to write down the network part as it is, and the host part we have to put all 0. Network ID, by definition, network ID is an IP address where the host part is completely 0. So this is the range that is given to me. In this range, we need to find out what part is the network part and what part is the host part. How can we find out the network part and the host part? The part that is common in all the IP addresses, that is what we refer to as the network part, and the part that is changing in all these IP addresses is what we are going to refer to as the host part. So how to find the common part, how to find the changing part, convert these into binary. So I can see clearly that 7.7 is same everywhere. That is why I did not write down the binary for the same. So I just write down exactly like that. I can see that the changes are happening in the third octet. So I write down the third octet in the binary. I write down the third octet in the binary. And in the third octet that is written in binary, I do not care about the fourth octet because fourth octet could be anything. So since the changes are happening in the third octet, I need to worry about the third octet. So here you can see that if you write down this third octet in binary, you can find out that first 5 bits, the first 5 bits are exactly the same. 0, 0, 0, 0, 0, 0, 0, 0, 0, all these are same. And it is the 6th, 7th and 8th bit where the changes are actually happening. So in all the IP address, whatever part is common, this part is common. This part is common in all the IP addresses, and this part is the part that is changing in all the IP addresses. So I have to write down this common part as it is 1, 2, 3, 4, 5. I have to write down this common part as it is, and the part that is changing, the part that is that is having different values. That this part is I'm going to consider as the network part, and this part, the last part, is what we are going to consider as the host part. And if I want to write down the network ID, the host part should become all 0. So first of all, I'm going to write down the given range into binary. First of all, I'm going to write down the given range into binary. Then I'm going to find out how many bits are exactly the same. The number of bits that these bits that are these part that is exactly the same, it is what we are going to consider as the network part. And the part that is changing, like last bits, these are changing, we are going to consider that part as the host part. And to write down the network ID, this part is the network part, this part is the host part. So to write down the network ID, host part must become all 0. So I put the network part as it is, I put the network part as it is, and I put the host part as all 0. So the result came to be 7.7.0.0. This is going to be the network ID. If you have any other way of calculating the network ID, you can try that. But we need to find out the network ID. We need to find out the common part in all these IP addresses. And now we have to write down that common part as it is. And the part that is changing, we are going to consider this as the host part, and we are going to put all 0 in that place. And we are going to get the network ID. So network ID of this given range, network ID for this given range is going to be 7.7.0.0. And now we need to write down the wildcard mask as well. So how can we find out the wildcard mask? The part that is common. Wildcard mask basically is to tell the access control list what part of the IP should match, and what part of the IP you do not care. I need to tell the router that if you are receiving a prefix, if you are receiving a route information, and that route information has the first octet as 7, match it. Second octet as 7, match it. In the third octet, if first 5 bits are 0, 0, 0, 0, 0, then the packet will be considered as match. And rest like part, I do not care. So I need to tell the operating system again, I need to tell the iOS what part of that prefix must match and what part of the prefix I do not care. So as we can see that in this given range, this part must match and this part is don't care. So you have to write down the wildcard mask. To calculate the wildcard mask, consider the network part as the must match and the remaining part as the don't care. Must match is in wildcard mask is represented by 0 and do not care is 1. So first octet must match, second octet must match, third octet 5 bits in the third octet must match. So 0, 0, 0, 0, 0, and I do not care about the 6th, 7th or 8th bit of the third octet, and I do not care about the last octet. So the wildcard mask is going to become 007.255. So if we need to match that range, this is the network ID and wildcard mask you can write down. Similar to that, we have to match only 5 prefixes. Unfortunately, you cannot do that. You cannot just match 5 prefixes. You just cannot do that. You cannot match just 5 prefixes. There is no way you can match just 5 prefixes by using that statement. You just cannot do that. Remember that range can never be random. It can never be random. Range will always be in 2 raised to the powers. The range will always be either like 1, 2, 4, 8, 16. There is no number 5 here. We cannot unfortunately match the prefixes exactly 130 or 120. We cannot match it like 130.100 to 5 we cannot match, or 0 to 0 to 5 we cannot exactly match. But anyway, access list permit, I need to write down 120.1.0.0, 0.0.7.255, and access list 50 permit 120.1.0.0, 0.0.7.255, and access list 50 permit any, deny any. So I have configured an ACL. In that ACL, whatever prefixes I want to match, permit. Whatever prefixes I don't want to match, deny. Write down the range that is given to you in binary. Write down the range that is given to you in binary and try to find out the network ID and wildcard mask that represents the entire range. And the approach to find out the network ID and wildcard mask is like that. Write down the entire range that is given to you, convert it into the binary, and see how many bits are matching and how many bits we don't care. Whatever bits are matching, you have to write down them as it is, and whatever bits are don't care, just set all 0 in that. Done. This is how we can configure the access control list that matches our desired prefixes, and after matching the desired prefixes, it is going to allow or deny the prefixes accordingly. Any doubts, if you have, let me know. There could have been another way, like you write down the network ID and subnet mask that represents this entire range. You can write down the network ID and subnet mask that represents this entire range, 7.7.0.0 to 55 to 55 to 48.0. Finding out the subnet mask is very easy. Like first octet, network part, network part, network part. Network part in the subnet mask is represented by 1. So 255, 255, and then 1, 2, 3, 4, 5, which is going to be 248. So the another way could have been like write down the network ID and subnet mask that represents the entire range, and then convert this subnet mask into the wildcard mask. To convert the subnet mask into the wildcard mask, all you need to do is to basically subtract it from all to 55. The result will be the same, 0007 to 55. This technique might not work always. That's why we generally do not use this, but it could also be one way to write down the network ID and wildcard mask. This technique sometimes does not work exactly like intended. So, and then this is how we can configure the ACL. And now if you want to apply it, how can we apply it to perform the route filtering? We need to go to the routing protocol, such as router OSPF, router EIGRP, or router RIP, whatever. And we need to use the command called distribute list. Distribute list is the command that we need to use. Distribute list is the command that we can use to actually call this access control list to perform the route filtering. Distribute list number 50. 50 basically means the ACL number. Distribute list 50. Distribute list 50 basically means that I am going to use the ACL number 50 to perform the route filtering. Same command we can use under the EIGRP, same command we can use under RIP. The command is distribute list number 50 and then in. In means incoming updates, out means outgoing update. In means when we receive the update, we are going to filter. Out means when we advertise the updates, then we are going to filter. At the moment, we want to filter all the prefixes that I am receiving. So the command is distribute list 50 in. The command distribute list is going to filter the prefixes based on the ACL. Distribute list is the way, distribute list is the command that we use to filter the prefixes that we use to call the ACL that we have just configured. Just like in case of data filtering, just like in case of route filtering, data filtering, there we use the command IP access group. Here we use the command distribute list. Okay, and you check do show IP route OSPF. You can see that only 120 and 130 prefixes should be there. Only 120 and 130 prefixes should be there. So 120 prefixes are there. I'm not receiving 130 prefixes. Were I receiving 130 prefixes earlier? Let me cross check. Yes, we were receiving 130 prefixes as well. 130.1.0.0, that is fine. Those prefixes should be here as well. To show run pipe section router OSPF. So the command is router OSPF, router ID, distribute list 50 in, and do show IP access list number 50. So 120.1.0.0 wildcard mask, it is okay. 130.1.0.0 and the wildcard mask is okay as well. And then permit any 130 prefixes. We can cross check 130, 130.1/24. Yeah, it's okay. Let me cross check again if I'm receiving the prefixes on the other routers or not. Let's see on router number 5, am I receiving those 130 prefixes or not? Yes, here we are receiving those prefixes. So let me do one thing. Let me go to router number 3 and let me try to clear this OSPF process. Clear IP OSPF process. Anyway, this command allows you to filter the prefixes based on the ACL. Distribute list command is what we have to use. This distribute list command is going to filter the prefixes as per your requirement. So like first you configure the ACL. In that ACL, you define what you want to permit, what you want to deny, and then you apply that ACL with the help of the distribute list. It should actually show IP route OSPF. It should show you 130 prefixes as well. Okay, configure terminal. Do show IP access list. Doesn't look like the 130 prefixes are matching here. Neighborship is okay. Do show run pipe section. Do show IP protocol. So it says that incoming update filter list is 50. That is fine. So show run pipe section router OSPF. Do show run pipe section router OSPF. That is okay. Distribute list is also okay. And do show IP route OSPF. I am receiving all those prefixes, but I'm not receiving 130 prefixes. On router number 8, let me do one thing on router number 8. Do show run pipe section router OSPF. Let me remove this and apply it again. Let's see what happens. Let me remove this redistribute command and apply this again. Redistribute RIP. Let's see what happens now. LSAs are there, as I can see, 130.1.130, looks okay. So do show IP access list. It somehow it's not matching in here. ACL is correct. 130 dot, not sure what is the, no access list 50. Again, access list 50, then permit 120 dot 1 dot 0 dot 0, and access list 50, permit 130 dot 1 dot 0 dot 0, and access list 50, deny everything else. Still, it's not matching those prefixes. Okay, it could be because we have configured NSSA here. Let me do one thing. Let me remove this NSSA configuration from these routers. Router 7. Okay. So configure terminal, do show run pipe section router OSPF. So here I'm going to say no area to NSSA, and same command I'm going to use everywhere else. Router 5, I'm going to use the same command. Router number 7, I'm going to use the same command. And router number 8, I'm going to use the same command. No, it's still not sure what is the issue, because ACL is applied correctly, 130 subnet is there, and same thing I can confirm the routes that are here, and then 30 prefixes are here itself. It should filter. Not sure why it's not filtering. Let me do a clear as well. Clear IP OSPF process. Check it again. Show IP route OSPF. Now it's there. Not sure what was the issue. Those prefixes are now it's okay. Now it is fine. So might have been some problem. ACL was not matching those prefixes due to some reason, but now the ACL is matching those prefixes. As a result, we got all those prefixes in the table. Might be some issue. You can try once in your lab as well. So the point is that when we configure this ACL, when we configure this access control list, in the ACL directly we need to specify. In the ACL directly we need to specify what prefixes we want to permit and what prefixes we want to deny. Whatever prefixes we permit are going to be permitted. Whatever prefixes we deny are going to be denied. And based on that, you will receive the routes in the routing table. So first configure the ACL, then configure pipe section router OSPF, then configure like router OSPF, configure the distribute list and everything. And then you should see the filtering will happen exactly based on the ACL that we have configured. Whatever we have permitted in the ACL is allowed. Whatever we have denied in the ACL is denied here. Okay. Now this command that we have applied, this command is going to filter the prefixes on all the interfaces. We can also mention that I don't want to filter anything on FA 0 by 1. I only want to perform the filtering on 0 by 0. So instead of configuring this, I could have done this as well. I could have said like distribute list 50 in and the interface FA 0 by 0. I can also mention the interface after that. It means that I am going to filter the prefixes, but only on this interface. I am going to perform the route filtering, but only on the interface FA 0 by 0. So instead of just configuring the route filtering on all the interfaces in a generic way, we can perform the route filtering on one specific interface as well by mentioning the command, by mentioning the interface after the command. And we can now say do show IP route OSPF. We can see that on FA 0 by 1, 2 by 0, on everywhere I'm receiving everything. On everywhere I'm receiving everything, but on FA 0 by 0, we are not receiving like, you know, these prefixes. We are not receiving prefixes other than these ones. On fs0/0, I'm going to receive like these prefixes and I'm going to deny everything else. But on rest of the interfaces, I'm going to receive everything. You can see that 130 and 120, they are available on 0/0, 0/0, but on all the rest of the interfaces, all the prefixes are being received. So we can also mention that I do not want to filter the prefixes on all the interfaces. I want to filter the prefixes on some specific interface. That thing can also be done. So we have options. We have one option. We have one option that we can filter the prefixes. We have one option that we can filter the prefixes on all the interfaces in general, or we can filter the prefixes on some specific interface. Similar to this, we can mention out. Out means I am going to receive the prefix, but when I advertise the prefix to the neighbor router, I am going to perform the filtering. Out means out, like when I send the update out of all the interfaces, I am first going to filter the prefixes based on the ACL. Or if you have mentioned out any specific interface, that means if we want to filter, if you are going to, when you advertise the prefixes out of that specific interface, then only you are going to perform the filtering. So just like in interface, similar to that, we have out interface as well. In interface and out interface command is there as well. Remember that in OSPF, applying the distribute list in out direction will not work, because this distribute list is going to filter the routes. And again, OSPF does not advertise the route. OSPF advertises the LSA. So this command does not work in OSPF in out direction. This will just not work. Distribute list 50 out, this will just not work. This command will just not work in OSPF routing protocol. In other protocols, it will work, but it will not work in the OSPF routing protocol. Why it will not work in the OSPF routing protocol? It will not work in the OSPF routing protocol because in OSPF, like LSAs are advertised, not the routes, and this command filters the routes, not the LSAs. So we have the options now. You can see we have the options: distribute list in interface, out interface. We have the option, and you can keep changing the ACL as per the requirement. You can keep changing the ACL. You can add the entries in the ACL. You can remove the entries in the ACL. You don't need to apply the again and again in the distribute list. Changes can be made in the ACL as required. We don't need to apply the ACL again and again in the distribute list. And to verify if the filtering is done or not, we can use the command show IP protocol, and there we can verify if the filtering is being done or not. Again, let's say another example. Let's say we want to filter these 4 prefixes this time. Another example, let's say we want to filter these 4 prefixes. 7.7.4, 5, 6, 7. We want to filter only these 4 prefixes. So I'm going to write down these 4 prefixes in binary. I'm going to see what part of these 4 prefixes is common, because that part I'm going to consider as the network part, and that must not change. That must be written as it is. So I saw that 7.7 is common everywhere, and in the third octet, 1, 2, 3, 4, 5, 6 bits are same. So I will write down 7.7.000.001. Whatever it is, I'm going to write down as it is here. So this part is going to be considered as the network part. And the remaining, because this part is common in all the IP address, all the IP addresses that we have to match, this part is the common part. So that part will be the network part, and the remaining part is going to be the host part. And as per the definition of the network ID, the host part must be all 0. So I have written down the network part as it is, and I have written down the host part as all 0, because as per the definition of the network ID, the host part should always be 0. So if I convert it into the decimal again, it will be 7.7. And this is written as 4. 100 is equal to 4. So the network ID will be 7.7.4.0. And the wildcard mask 0.0.1234567 and 11111, so 255. So the wildcard mask is going to be 0.0.3.255. So the ACL will be 7.7.4.0, 0.0.3.255. You can apply the same logic for your 120 prefixes. You can apply the same logic for 130 prefixes. You can apply the same logic for any subnet that you want to match with the help of the access control list. We can also apply the distribute list in one direction. Now, so we have the command distribute list one in. We have the command distribute list one in on interface. We have the command distribute list one out. We have the command distribute list one out on a specific interface. In means incoming updates are going to be filtered. In interface means incoming updates are going to be filtered on a specific interface. Out means outgoing updates are going to be filtered on all the interfaces, and out interface means outgoing updates are going to be filtered specifically on this particular interface. Also remember, we cannot apply more than one ACL in one direction. Like we cannot say distribute list one in, and we cannot say like just below that we cannot say distribute list two in. We cannot say that. In one direction, one ACL will be applied. That rule is still applicable in the route filtering as well. This rule is also there in the traffic filtering, that on one interface we cannot apply more than one ACL. That rule is still applicable on here as well. That means distribute list one in. That means now we cannot apply distribute list two in. Distribute list one in on interface, we cannot apply distribute list two in on the interface. On one direction, we can apply one. You can do that. Distribute list two out, distribute list three out on interface. You can do all that, but you cannot apply multiple ACL in the same direction. That rule is still applicable. Any doubts if you have, let me know. Any questions, if anyone has, let me know. Any question, if you have, you let me know. Not only that, see, we can apply in, we can apply like on like normal, we can apply in, we can apply in interface. We can also do this. Let me show you. We can also do this. See what I'm doing. Access list 50 permit 120.1.1.0 or access list 150, access list 50 deny 120.1.0.0, 0.0.7.255, and access list 50 permit any. Then access list 60 deny 130.1.0.0, 0.0.7.255, and access list 60 permit any. I have configured two ACLs this time. One, I am going to configure like the command distribute list 50 in, and the second I'm going to configure distribute list like 50 in and on a specific interface like 2x0. It is completely possible. Sorry. It is completely possible that we can apply one ACL for all the interfaces, and we can apply one ACL specifically on that particular interface. Do show run pipe section router OSPF. We have two ACLs now. We have two ACLs applied here. One ACL that is applied here is the distribute list 50 in, and the other ACL that is applied here is distribute list 60 in on a specific interface. What does it mean? It means that when the update will arrive on the interface, it will be filtered by this, and in general on the rest of the interfaces it will filter with this. Actually, it's not like that. Do not think that this command is going to filter the prefixes specifically on the interface FA2x0, and this command is going to filter the prefixes on all the rest of the interfaces. It's not like that. This command basically means, see, on all the interfaces, first ACL number 50 will be applied to filter the prefixes. On all the interfaces, ACL number 50 will be applied to filter the prefixes. And then specifically on the interface, the prefixes are also going to be filtered with the ACL number 60. That means on FA2 by 0, filtering will be done by two ACL, 50 and 60. See, show IP protocol. Here, incoming updates on all the interfaces will be filtered by ACL number 50, and interface FA2 by 0 will be filtered by 60 as well. So see, so first of all, on all the interfaces, the ACL 50 is going to perform the route filtering. And what do we have denied in the ACL 50? Show IP access list number 50. We have denied 120 subnets. That means 120 subnets will not be available anywhere. On all the interfaces, we have filtered this subnet. So do show IP route OSPF pipe, pipe include 120.1 subnet is nowhere. This 120 subnet got filtered everywhere, right? 120 subnet got filtered everywhere, and the rest of the prefixes were allowed. Rest of the prefixes means everything other than 120 is now allowed, and allowed on all the interfaces. And when the prefixes are received on FA2 by 0, additionally, the ACL number ACL number 60 is going to perform the filtering as well. That means on FA, show IP route OSPF pipe include 130.1 subnet, you can see those prefixes only and only on 0 by 1. You do not see those prefixes on here. Otherwise, if only one ACL was being applied, then 130 subnets you should have received on here as well as here. Because as per the ACL number 50, I am going to block 120 and allow everything else, but that doesn't look like the condition. The 120 prefixes are filtered on all the interfaces, and 130 prefixes got filtered on the interface FA2 by 0. Then the rest of the prefixes got installed in the routing table. As you can confirm, we do have the prefixes in the routing table, but after the filtering that is done as per our requirement. So 120 subnet is not there anywhere, and 130 subnet got filtered on this interface as well. This right here. Here. We can apply like multiple ACLs as well. We can apply multiple access control lists here as well. On one router, we can apply an ACL. That ACL says I'm going to deny these prefixes, permit everything else. And this ACL says I'm going to permit these things. So I can apply the ACL on this specific interface, and then we can apply in general on all the interfaces as well. It is completely possible to apply multiple ACLs, but not in the same direction, in the different direction. Only one ACL in one direction. Doubts, let me know. You can configure instead of configuring the numbered ACL, you could have configured the named ACL. Show IP access list. You could have said like configure terminal, IP, access list, standard, Cisco, then permit 120.1.0.0, 0.0.7.255, permit 130.1.0.0, 0.0.7.255, and then deny everything else. And then router OSPF1, distribute list, the name of the ACL, and either in direction, out direction, in on interface, out on interface, we can also apply the named ACL. And you see, as soon as you apply that named ACL, the previous ACL got removed. So we cannot apply multiple ACL at the same time. So you could have configured a named ACL as well. Standard ACL is just going to filter, standard access control list is just going to filter the prefixes based on IP address, like source IP address. And in the source IP, we need to specify the prefixes that we want to filter. No matter if it is a standard, extended, does not matter what type of it is, like named or numbered, does not matter what type of it is, can be applied exactly the same way. This is how we can perform the route filtering using standard access control list, either named or numbered, in interior gateway protocols. Any doubts if you have, you let me know. Now, same can be done with the help of extended access control list. However, the extended access control list can match based on two things. Extended ACL can match based on two things. In the extended ACL, we have to specify source as well as the destination. Remember, we are talking about IGP protocol. When we talk about BGP protocol, this works very differently. So we are just talking about IGP. When we want to perform the route filtering using the extended access control list, in the extended access control list, we can match both source and destination. We write down the access control list where we need to match the source and the destination. So while creating the extended access control list to perform the route filtering, in the source, we match from where we are receiving the update. Routing update source means source IP. Source IP of the update message. From where you are receiving the. Earlier, we were doing that by mentioning the interface. Like we no longer need to mention the interface now because we can specify it directly on there. So in the source, we need to match the routing update source, and in the destination, we need to match the prefixes that we want to filter. So for example, again, let me remove the ACLs that we have applied on the OSPF. So here, I'm going to remove this distribute list, and I'm going to remove the other distribute list as well. Let's try it in other protocol, any other protocol. Let's say, for example, EIGRP protocol, router 11 maybe. So I am receiving all the prefixes again, as usual. I'm receiving all the prefixes. Do, show, run, pipe section, router EIGRP. Let me remove that distribute list that we have, distance that we have configured. So on router number 11, I am receiving all the EIGRP prefixes. On router number 11, I'm receiving all the EIGRP prefixes, as you can see. On both the path, I'm receiving all the EIGRP prefixes on both the path. I do not want to receive any prefix from this path, only and only this path. And I want to use ACL for the same. I do not want to receive any of these prefixes from this path. I do not want to receive any of these prefixes from this path. So configure terminal, access list 150, deny IP, host. Why the host keyword? Because I want to match a specific IP address, a specific source I want to match. So host, otherwise you could have used the 000 wildcard mask as well if you did not use the host keyword, completely your choice. So access list 150, deny. I want to deny prefixes from this host, and then in the destination part of it, I want to mention the prefixes 120.1.0.0, 0.0.7.255. Access list 150, permit IP any. This ACL says deny these prefixes from this source, deny these prefixes from this source, and then permit all the other prefixes from all the other sources. And then apply this exactly in the same way. Distribute list 150 in interface and whatever you want to apply, you can apply the same, exactly the same. Access list 150, deny IP host, then access list 150, permit accordingly, and then You can just check the routes, do show IP route EIGRP. You can see all those prefixes are gone from 100 subnet. They are now being received only from there. You can check do show IP access list that your ACL is matching the prefixes properly. 5 prefixes got matched and filtered. So when it comes to the extended access control list, we have 2 things to specify. One is the source, one is the destination. In the source part of the extended ACL, we need to match the source from where we want to do the filtering. And in the destination part of this extended ACL, we need to match the routes that we want to filter. So we want to filter these routes from this source that we have specified and permitted everything else, and then applied it exactly the same way as we applied the standard ACL. We do not need to mention the interface here because anyway we are mentioning this thing here. So no need to mention the interface. Okay. You can configure the named ACL as well. Do it yourself. You can configure the named extended ACL as well, completely exactly the same way as we did for the numbered one. So do it yourself. And that's it. This is how we can use the extended ACL, either named or numbered, to perform the route filtering in interior gateway protocol. Also remember that if you have removed the access control list, if you have deleted the ACL, but you did not remove it from the router EIGRP, for example, router OSPF, for example, you have deleted the ACL. You have deleted the ACL, but you have not removed the ACL from the protocol configuration. That ACL will not have any impact. Means that all the routes will be available. So this does not make any sense if you have not created that particular access control list. This is how we can use the access control list to filter the prefixes as per our requirement. We can use the ACL to perform filtering. We cannot do path manipulation. It will just filter. It will either permit or deny the prefixes, and that's it. ACL will just filter, just pure, like in the distribute list when we have used the ACL, it will just purely filter the prefixes. It will not do the path manipulation or anything. It will just filter it. In case of AD, we had the option to either filter it or do the path manipulation as per the requirement. But in the ACL, that's not the condition. It will just filter it. Use the standard ACL or the extended ACL, named or numbered, completely your choice. Now, this is very basic matching. This is very basic matching that we have done. We can also do some complex matching in the access control list. We can do some complex matching with the help of the ACL as well. So let's say on router number 9, let me configure 2, or router number 10, let me configure 2 loopbacks. Now, interface loopback 10, IP address 1234, IP OSPF1 area 3, interface loopback 11, IP address 4321, and IP OSPF1 area 3. I have configured 2 loopbacks on router number 10. One is 1234, second one is 4321, and both are part of the area 3. That means if I go to router number 3, for example, I must see these prefixes to IP route OSPF. 1234, as you can see here, 1234 is here, and of course I should have 4321 here as well. The requirement is you only need to permit these 2, or you only need to block these 2 and allow everything else. You need to match. You need to match in the ACL 1234 and 4321. You might think that this actually cannot be done, but it can be done. You have to write down a network ID and the wildcard mask in such a way that matches 1, 2, 3, 4, 4, 3, 2, 1. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. This is binary representation of the same. So here now it is going to be 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. You have to write down a network ID and wildcard mask in such a way that it matches these two. How to write down the network ID? To write down the network ID, whatever part is common, you have to write down that part as it is. Whatever part is common, you have to write down that part as it is, and then the rest of the part is going to be 0. So in these two, 1, 2, 3, 4, 5, 5 parts are exactly the same. So 1, 2, 3, 4, 5 is exactly the same. Okay. In here, 1, 2, 3, 4, 5, 6, 7 bits are exactly the same. So 1, 2, 3, 4, 5, 6, 7 bits are exactly the same. Here, 1, 2, 3, 4, 5, 6, 7 bits are exactly the same in both of the IP, as you can see. You can draw the line here for better understanding. You can draw the line here for better understanding. You can draw the line here for better understanding. You can draw the line here for better understanding. 1, 2, 3, 4, 5 parts are exactly the same. And rest of the part is changing. 3 bits here, 1 bit here, 1 bit here, 3 bit here. It is going to be 0, 0, 0, 0, 0, 0, 0, 0. Because the part that changes is considered as the host part, and host part is going to be 0 in case of network ID. Okay. What is the network ID then? What is going to be the network ID? It is going to be 0.2.2.0. Completely valid. This is completely valid. Okay. Now, the wildcard mask. How to write down the wildcard mask? The part that is same in both, it has to be must match, and the part that is changing, it will be don't care. So first bit is matching in both, second, third, fourth, fifth. These 5 bits are matching exactly the same. 6th bit is changing, so it will be don't care. 7th bit is again matching, so it will be 0. 7th, 8th bit is changing, so it will be don't care. Whatever part is same in both, 0. Whatever part is different, 1. Must match, don't care. So 1, 2, 3, 4, 5, 6, 7, don't care. 1, 2, 3, 4, 5, 6, 7, and don't care. 1, 2, 3, 4, 5, 6, 7, 8. What is this wildcard mask? This is 5.1.1.5. Might not look like any ACL that you have created so far. So let's try this. So let's go on the router number 3 maybe. Configure terminal, access list 90, permit 0.2.2.0, 5.5.1, 5.1.1.5, and access list 90, deny any. Then router OSPF, distribute list 90 in. Okay. So configure the ACL, then applied it in the OSPF. Do show IP route or show IP route OSPF. show IP access list 90. Show IP access list 90. You can check show IP access list 90, and you can check show IP route OSPF. So ACLs are not that simple as you think. We can match any two IPs. Just remember the same concept. Whatever part is common, write down that as it is. Whatever part is changing, set it to 0. That's why I said that that rule will not always be true. That IP, subnet mask, inverted wildcard mask you will get. That is not always the case. Remember that whatever part is common in both the IP has to be must match in the wildcard mask, and the part that is changing, it will be don't care. So I compared like bit by bit, both the IPs I compared, and whatever part was common, whatever bits were common in both, I put the wildcard mask as 0, and whatever part was changing, I put the wildcard mask as 1, which gave us only those two things. Okay. Now, do it yourself. On router 3, you have to perform the route filtering in such a way that you should only receive those 120 subnets. You should only receive those 120 subnets that have an even number in third octet, and in 130 subnet, in 130 range, you should only permit those prefixes that have an odd number in the third octet. Rest, deny. We can do matching with like in the third octet, even number, fourth octet, odd number. We can also do that. Not going to do that much. Not going to make it that complex. But in 120 range, only what 120.1.0.0 to 120.1.7.255, not the entire 120 range. 130.1.0.0, 130.1.7.255. In this range, in this IP range, from 120 range, you should only have those prefixes in your routing table that have an even number in the third octet, and you should have only those numbers that have an odd number in the third octet from 130 range. What ACL statement you will write down. You have to do it yourself. Just to give you the hint, even numbers are those numbers that can be divided by 2, and odd numbers are those numbers that cannot be divided completely by 2. In short, in even number, once we divide any even number by 2, the remainder will always be 0. And if we divide any odd number by 2, the remainder will always remain 1. This is the hint that you have to take. So this completes route filtering with the help of the access control list. The limitation of the access control list is that the only thing that we can match on is the prefix itself. Like prefix is the only thing that we can match. We can match the range only. But maybe in my routing table, we have prefixes on different CIDR, and we want to match the prefixes, block the prefixes, allow the prefixes based on CIDR. That cannot be done with the help of the ACL. That will be done with the help of the next concept, prefix list, which we will talk about tomorrow. Prefix list, area filter list, and that we also have offset list. Actually, we'll talk about all these things by tomorrow, and then if some time is remaining, then we'll talk about the route map. Otherwise, we'll talk about the route map in the next class. So for today, complete this AD, 3 variations of the AD value to perform the route filtering, ACL, a standard extended name number, and try to complete the question that is given to you, even odd one. And tomorrow we'll talk about the filtering based on the prefix list, area filter list, and the offset list. Once it is done, we'll move on to the route map concepts. We will see what is a route map and the use cases of the route map in variety of things. ACL was done. In last class, we did talk about the standard access list, extended access list, named and numbered, that can be used to perform the route filtering respectively. Now, the next thing that we have here is the prefix list. Prefix list can also be used to perform the route filtering. And this prefix list comes very handy when we need to match the prefixes in a certain range. Not only we need to match the prefixes in a range, but we also need to match the prefixes based on CIDR. Like if you need to match the prefixes based on CIDR, if we need to match the prefixes based on range and CIDR. Let's say, for example, we are given that if you need to block certain prefixes, you need to block the prefixes from this range, from 1.1.7.255, that you need to block the prefixes in this range, but only and only those prefixes you need to block that are coming on the CIDR /27 to /30. So like if you need to block a set of prefixes, or if you need to permit a set of prefixes that are coming on a specific CIDR, a specific classless interdomain, a specific CIDR, a specific subnet mask, then this ACL concept is not going to work properly. Because in case of access control list, in case of ACL actually, what you will need to do in case of access control list, you need to check your entire routing table. And in your routing table, you need to find out like what prefixes are coming in this range, and they are in that particular subnet mask range. You need to match those prefixes one by one. In the access control list, you need to write down. In the ACL, you will need to write down the prefixes with the appropriate subnet mask, respectively. So you will create first of all, you will check your entire routing table. In your entire routing table, you will find out what prefixes are coming in the /28, /29, and /30, for example. And then you are going to either permit or deny the prefixes based on the same. So it can be done. Like it's not like we cannot do it with the help of the ACL. It can be done. Like let's say, for example, in your entire routing table, let's say for your route, for example, in your entire routing table, there should not be any prefix with the subnet mask /28, /39, /30. That can be done with the help of the access list as well. You can do it with the help of the ACL, but the problem is that then in that case, you need to check the entire routing table. And in the entire routing table, you need to find out what prefixes are coming on /28 masks, what prefixes are coming on /29 masks, and what prefixes are coming on /30 masks. Once you have found that out, then you are going to use permit or deny statements in the ACL, and you are going to match them one by one, which might be suitable for a small network. But if you have like thousands of prefixes in your routing table and you just want to filter some prefixes based on the mask, then using the ACL might not be a very good idea. We can use other techniques as well. We can use techniques such as prefix list. So prefix list like is used specifically in the case when we have to match the prefixes based on the CIDR. Like we can match the exact prefixes as well that we want to block, or we can match the prefixes. We can match a range of prefixes that is coming on a specific CIDR. Prefix list allows us to match the prefixes based on a specific CIDR. Prefix list allows us to match the prefixes based on a specific CIDR as well. And prefix list is very widely used in things such as like route filtering, path manipulation. You will find that prefix list is very widely used in these situations. For example, when we talk about protocols such as BGP, Border Gateway Protocol, you will see that protocols such as BGP very extensively is going to use the prefix list to perform the best path manipulation, change in the path attributes, and also ACLs we can also use, but prefix list is also one way to do the same. So in prefix list, let's say, for example, we are given a range. Let's say in the prefix list, we are given a range that in the entire routing table, we have to block those prefixes that are coming on the CIDR /28, /29, and /30. And in maybe in the entire routing table, we need to permit only those prefixes that are coming with the CIDR to the CIDR. So we can create a prefix list for the same. How can we create the prefix list for the same? We can use the keyword called IP prefix list, the name of the prefix list. We can also specify the sequence number of this statement, just like in ACL. The sequence number is incremented by 1. We can also specify it manually as well. Here also, we can specify the sequence number all by yourself. If you do not specify the sequence number of the statement, prefix list is automatically going to add a sequence number 5, then 10, then 15, then like 555, it will increment the sequence number for the same. So if a prefix list has multiple statements, such as this prefix list has 3 statements, first statement will have the sequence number 5, second will have 10, third will have 15. So IP prefix list, name of the prefix list, then either permit or deny or whatever. Then here you need to write down the prefixes that you want to permit or deny. Remember that prefix list uses a concept of less than equal to, greater than equal to. Prefix list uses a concept of less than equal to, greater than equal to specify the CIDR range. This less than equal to, greater than equal to is used to match the CIDR range. Like I want to block the prefixes from this CIDR to this CIDR, so that can be defined in the greater than equal to or less than equal to symbol. So greater than equal to, less than equal to, actually in prefix list is used to, in prefix list, the greater than equal to, less than equal to is used to actually match this greater than equal to, less than equal to is basically used to match the CIDR. So greater than equal to means if a prefix has a subnet mask greater than or equal to 28, then match it and deny it. Or if the prefix list, if the prefix has the subnet mask like less than or equal to 30, then match it and deny it. So this command greater than equal to, less than equal to, this command is going to match the range of the CIDR. Let's say, for example, 28 to 30. So greater than equal to 20, greater than equal to 20, and less than equal to 30. So it will automatically match like 28, 29, and 30 CIDR. So based on this greater than equal to, less than equal to, we are going to match the CIDR. We are going to match the prefixes. We are going to match the CIDR based on this greater than equal to or less than equal to. If we have specified just greater than equal to, if we have specified just greater than equal to, such as, for example, greater than equal to 28, that means it is going to match 28, 29, 30, 31, and 32. It is going to match all the CIDRs greater than equal to 28. And if we have specified such as like less than or equal to 30, it means it is going to match all the CIDRs less than or equal to 30. So 30, 29, 28, and then so on. So we can also specify these individually. Not necessarily we need to specify both of the thing. If you specify both of the thing, it is going to match a range of the CIDR. If you do not specify like both of the thing, maybe you have just specified the less than equal to, that means less than equal to CIDR 32, everything will match, or greater than equal to, just in case if you have specified only, that means greater than equal to that CIDR, it is just going to match. Now, if you do not specify anything, you have neither specified the greater than equal to or nor the less than equal to, you have not specified like greater than equal to or less than equal to, like none of these. If you have not specified either greater than equal to or less than equal to, in that case, the prefix this is going to match this prefix as it is. It is not considered as a range. It is not a range. It becomes the range. Like I want to perform the filtering in this range. This becomes the range only and only when we have specified the greater than equal to, less than equal to, or maybe greater than equal to, less than equal to, both, all, only in that condition. If you have neither specified the greater than equal to, nor you have specified the less than equal to, in that situation, this is not a range. This is the exact subnet, exact route that you want to either deny or you want to filter. In this condition, for example, this statement, this is the default route. This is going to match the default, match one individual prefix. In this case, it is default route. If it was, let's say, for example, 10.0.0.0, it was 10.0.0.0/16. It was not a range. It was not a range. If it was like 10.00/16, it was not a range. It is not from 10.0.0.0 to 10.255.2. It is not that. It's 10.0.255.2. It is not a range. It is not. It is exact this prefix. Like 10.0.0.0/16. Like if you have a route in your routing table, this one, it will be denied. It becomes range only when we specify like we want to perform the filtering from this range to this range. If you need to specify that you want to perform the filtering in this range on a specific CIDR, you need to mention that CIDR here in the format of greater than equal to, less than equal to, either both or individually, completely up to you. But until you specify this greater than equal to or less than equal to, this will not be treated as a range. So following the same concept here in this topology, we have a lot of prefixes. We have different prefixes. What I'm going to do now, I do have like these prefixes. We have these different prefixes. What I'm going to do now, I'm going to change the CIDR of these prefixes 120. I'm going to change the CIDR of these prefixes 130 to like some random numbers. So I will go to router number 12. I will go to router number 13. And on router number 12 and 13, I'm going to change the CIDR of the prefixes to something random. Right, so maybe I'm going to create a few more loopbacks as well. So I'm going to basically loop back 1, loop back 2, loop back 5, and loop back 6. I'm going to configure loop back 6 with the IP address as well. And I'm also going to configure a loop back 7. Right, so loop back 7 is going to be 7, is going to be 6. Okay, so yeah. This is 130.1.1.1. Okay, this is on like slash 24. Okay, so let me do it. 192, 25, 224, then 240, then 248, then 252, and 255. So I have changed the CIDRs. I have changed like the CIDRs of these prefixes here. So now the CIDR has become like some random numbers. So CIDR I have changed here. Same thing what I'm going to do, I'm going to change actually. Same thing what I'm going to do, I'm going to change the CIDR on that side as well, on the other side as well. So I'm going to change all these on here as well. Okay. So here it is changed, here it is changed. Also on router 9 also you have a few loopbacks you can check. Show IP interface brief. You have few loopbacks here as well. If you want, you can change the CIDRs here as well, completely up to you. But I'm going to let these come on the /32 mask itself. So show run interface loopback 0. It is on /32 mask. I will let it, advertise on /32 itself. So some prefixes now, if you check in the routing table anywhere, like let's say, for example, on router 3, you check the routes in the routing table, show IP route OSPF, you might see some prefixes here. Some prefixes here, they are coming on /32, some are coming on /24, some are there on again /32, and then we have 130 subnets that are coming, that are being advertised on different, if I say 27, 26, 24, different masks. And then we also have 120 subnets that are also getting advertised on different masks. So in my routing table now, we have different prefixes. We have different prefixes with different masks. So in the routing table, we now have different prefixes with different masks. And what is asked for us, like we are asked that on router 3, we should not have any prefix in our routing table that has a CIDR of /24. We are asked that we should not have in the entire routing table. In the entire routing table, we should not have any prefix in the CIDR with the subnet mask value of 24. So we are asked that you need to create some sort of route filtering mechanism in such a way that your routing table does not have any prefix on the CIDR /24. So we'll go to router number 3, and on router number 3, I'm going to say configure terminal, IP prefix list, the name of the prefix list. Then either you can specify the sequence number all by yourself. If you do not, it will choose the sequence number automatically. Then I'm going to say deny. What do you want to deny? Here now you have to represent the range. Here you have to represent the range in which you are going to perform the filtering. In what range you want to perform the filtering. Here you need to specify the IP address and subnet mask in such a way that it represents the range in which you want to perform the route filtering. So here you need to specify the range in the format of IP address and subnet mask. In the format of IP address and subnet mask, you need to specify the range in which you want to perform the route filtering. Since I want to perform the route filtering in the entire routing table, I am going to write down 0000/0. 0000/0 basically means that this is any IP, any mask, like the entire routing table. But if I hit enter right here, it is not going to consider it as a range. It is going to consider it as a default route. Because if I do not specify greater than equal to, or if I not specify the less than equal to, this will not be considered as a range in which we want to perform the filtering. Instead, it will be considered as a indivisible subnet that we might want to filter. So no, we cannot hit enter right here, because if we hit enter, the default route will be deleted from the routing table, and the rest of the routes might be permitted based on the statements that you will specify. But the point is, like IP prefix list, the name of the prefix list, then the deny, and right here we are actually saying that it is a range. It is not an indivisible prefix. We need to tell that it is a range. How can we do that? By specifying the greater than equal to and less than equal to after that. Now, we don't want any prefix on the CIDR/24. So what we need to write down? We need to write down that if I say greater than equal to 24, that means it is going to filter all the prefixes with the CIDR value of 24 and higher, 24, 25, 26, 27. So we don't want to do that. We want to limit it on single number, 24. So I'm also going to write down less than equal to 24. Greater than equal to 24, less than equal to 24 means 24. You cannot just specify EQ24 equal to 24. There is no such command. The command is only greater than equal to, command is only less than equal to. So what we should have done, we did greater than equal to 24, less than equal to 24, which means in a way 24. What is a number that is greater than equal to 24 and less than equal to 24? It is 24. So this is how we can match one CIDR. So now this will be treated as a range. Now the prefix list Cisco is going to block all the prefixes with the CIDR value of 24. The prefix list is going to block all the prefixes. The prefix list is going to block all the prefixes with the CIDR value of 24 in the entire routing table. In the entire routing table. In the entire routing table, all the prefixes with the CIDR value 24 will be blocked. And we also need to permit all the rest of the prefixes. So we just cannot say permit any. So what we need to say? IP prefix list Cisco permit again 0000 and less than equal to 32. This is permit any. This is any. Any means like IP mask, and then less than equal to. So this means that in entire routing table, all the other prefixes are permitted. So first statement, the IP prefix is Cisco. I'm going to deny in the entire routing table all the prefixes that have the CIDR value of 24. And in the second statement, I'm going to permit everything else, permit any. And then you can check it by the command show IP prefix list. You can see that I did not specify the sequence number. Sequence number got added automatically in 55. In ACL, it is in 1010, but in this prefix list, it is 55. And to apply this prefix list, same concept you have to use. You have to use the same distribute list concept, but you do not need to write down this like that. Because if you use the keyword distribute list and then the name and then in out or whatever, it will be considered as an ACL. So you need to write down distribute list prefix, and then you need to specify the prefix list, then the direction in or out. So in interface, out interface remains the same as the ACL that we discussed in the last class. This has no difference in terms of prefix list. The only change that you will see when it comes to applying that prefix list in the protocol such as OSPF is this keyword prefix. So this command says that I'm going to filter all the incoming prefixes with the help of the prefix list Cisco. That is what we mean by this command. Remember that we can also specify the interface, on which interface we want to filter. We can also specify out. We can specify out interface. All those things are discussed in the last class. You can refer to the recordings of the same. So that's it. This is how we create the prefix list, and this is how we apply the prefix list. So show IP route OSPF. If you check, you will not have any prefix in your routing table that is on the CIDR 24. You will not have any prefix in your routing table that has the CIDR of 24. You can see show IP route OSPF pipe include /24. So you don't have any 27. You do have the prefixes. 28, you do have the prefixes, but on 24, you don't have any prefix. So it is done. Create the prefix list, specify the permit or deny statement, and then use the router OSPF command, router EIGRP command, to router RIP command to filter the prefixes as per your requirement. So this is the range only when we specified a greater than equal to, less than equal to. If we did not specify greater than equal to, less than equal to, it is not a range. It will not be considered as a range. For example, now suddenly I remember that we don't need to block this. Suddenly I remember that we don't need to block this. Suddenly I remember that we don't need to block this. This has to be allowed. Suddenly I remember that this is allowed. This I want to allow actually. So show IP prefix list. I know in the prefix list, I know that if the things go to this statement, everything will be blocked. I know that if the things go to that particular statement, everything is going to be blocked. But I want to allow it. I want to allow those two certain prefixes. I want to allow those two certain prefixes. I want to allow this 200 subnet, 200.1.1.0 and 100.1.1.0. So if I write down the statement IP, prefix list, Cisco, permit 200.1.1.0/24, this is not a range. This is the indivisible prefix that you want to permit or block. But if you write down this command, the sequence number of this statement is going to be 15, which will go below this. And since everything is getting blocked at right this point on /24, it will never go to the next statement. So it doesn't make any sense that we apply this prefix list like that, IP prefix list and also. What we need to do after this, we need to specify the sequence number. Sequence number may be 3. I want this statement to be applied before this statement. Otherwise, as per the rules, when the router starts checking the prefix list, access list, it will always follow the top to down approach, top to bottom approach. And if the statement, if the prefix matches a certain statement, if it is permitted, it will be allowed. If it is denied, it will be denied. No further inspection will be done on there. Same IP prefix list, Cisco sequence number of 4 maybe, and permit 100.1.1.0. This is not a range. This is indivisible prefix. It's not like we need to permit or deny certain prefixes in this range. It is this specific subnet. It is this specific subnet. Like this statement says, I am going to allow only this subnet and I'm going to allow only this subnet. No CIDR if you have specified after that, it is an indivisible prefix, not the subnet. And you can see do show IP route OSPF. You have that 100 subnet here only, and you have that 200 subnet here only. Rest the /24 prefixes are not there. So 100 subnet we have, 200 subnet we have. show IP prefix list, you can use the statement to check. You can use this command to check what statements we have configured in the prefix list. So on router 3, basically, we are blocking the prefixes as per our requirement. We are blocking the prefixes as per our requirement. Fine. Show IP prefix list summary, show IP prefix list detail. You can also see, like, how many number of prefixes, how many prefix lists you have configured and all, the anytime the packet matches, hit count and everything, you can check it here as well. Now, this is a very basic use of the prefix list. This is where we did the filtering in the entire routing table. We don't need to do that. We did not want to do that. No IP prefix list Cisco. I want to do the route filtering, but I want to do the route filtering only in 120 and 130 range. I only need to perform the route filtering in 120 range and in 130 range. In the 120 range, I do not wish to receive any prefix on /26 to /28. And on /1 and on 130 subnets, I don't wish to receive any subnets on /29 to /31. So again, one more thing to remember, if we have not configured the prefix list and we have just applied that prefix list in OSPF, it doesn't mean anything. Like, you will still have all the route. The prefix list has no impact in the routing table if we have not created it. There's no prefix list named Cisco now, but it is still applied in the router OSPF. It will have no impact on it. So anyway, IP prefix list Cisco deny 120.1.0.0/21. What is the range in which we want to perform the filtering? The range is 120.1.0.0 to 120.1.7.255. This is the range in which we want to perform the filtering. So this IP address and the subnet mask, this IP address and subnet mask will give you that range of IP in which we want to perform the route filtering. This is the IP address and the subnet mask range. That in this range, actually, this is the range. The IP address and subnet mask we have mentioned, and this is the range in which we want to perform the route filtering. And then we need to specify, after that, we need to specify the greater than equal to 26 and less than equal to 28. Similar to that, IP prefix list Cisco deny 130.1.0.0/21 greater than equal to 29, less than equal to 31, and IP prefix list Cisco permit 0000 less than equal to 32. So this is only going to be considered a range after we have specified either greater than equal to or less than equal to. Otherwise, the route, this router will deny exactly this route in the routing table, which actually is not available. So if you just enter this, it's not like it is going to block all the prefixes in this range. No, it is going to look up, the device is going to look up for this exact route, and then it is going to perform the filtering. Done. Check it. Do show IP route OSPF. So you have rest of the prefixes. But if you check do show IP route OSPF pipe include 120.1. In this 120.1, you do not have any prefix from the range 26, 25, 26, whatever it was. So you have blocked that. And if you check the 130 range, in the 130 range, you don't have the prefix 31 and 28 and whatever you blocked it. So in 120 range, we have blocked 26, 27, 28. So those are not there. And in the 130 range, we block 29, 30, 31. So that is not there. So this is how we can create the prefix list as per the requirement and block the certain prefixes in the routing table. We can block the range. We can block individual prefixes from installing in the routing table. This is how we can use the prefix list for route filtering based on prefix itself, based on CIDR given in the prefix. Range is this. Range will be given to you, like in what range you need to filter. They will tell you that, okay, this range you don't need to receive these prefixes. So range they will tell you. You don't need to identify it in the document that you have from your company. They will give you the range that you need to perform the filtering in this particular range. Here we have selected the range as 120.1. Here we have selected the range as 130.1. In your production environment, you will be given a range in which we want to perform when you want to perform the route filter. Okay. Now, other than this, we can also perform the route filtering. I think like why that cable is not there. So other than that, we can also use the prefix list for a different purpose as well. Not only this, we can use the prefix list for some different purposes as well. This is how we can perform the route filtering with the help of the prefix list in simple. But like we can also use some other techniques for the same. No IP prefix list, Cisco, router OSPF, and I'm going to say like router OSPF and no command I'm going to use here. Let's go to maybe router number 12. Let's go to maybe router number 12. And here, let me do one thing. I'm receiving all the prefixes from EIGRP. As you can see, I can go to router number maybe 11, and there also I can see that I'm receiving all the prefixes from EIGRP. Now, I do not wish to receive any prefix from this gateway. I don't want to receive the prefixes from this gateway. I do not want to receive any prefix from this gateway. I want to receive the prefixes from this next hop only. I do not wish to receive the prefixes from this gateway. Yes.
So, sir, one query is that we are getting a prefix space of 123 for the class 16, right? But as per my company, I suggested to block the prefix of 26 to 28 then. So, how can I identify the route from the class 21 then greater than less than you have configured? I mean, class 21, how can I identify class 21 prefixes to come under this?
You cannot. You cannot. You have to check, like you have to use like show IP route and then pipe includes /21. So if you are saying that how what prefixes are coming on /21, you need to identify those. This is the way you need to identify this.
Basically, if the routes, what you are doing now, the routes what we are receiving, I mean, class 16 we are receiving, if class 16 we are receiving, now we have to do the filtering on the basis of class 16, then the range we will define. There is no reason what we have to define, but how the /21 is coming, it is not understandable to me.
/21 is coming because like this we have already discussed here. Like in the last class, we discussed how to find out the range here. So like
this one.
Yeah. If for example if you are saying that how can we create that particular range, so it is based on the same thing. For example, we wanted to perform the filtering in this range, so I had to write down a network ID and subnet mask in such a way that actually matches all the prefixes. So write down all the prefixes that you have to match, convert it into the binary, find out the network part, find out the host part, find out the network ID based on the same thing that we have done in the ACL in the last class. And just instead of using the wildcard mask, we need to find out the subnet mask. So you don't need to do a lot. Just check here, like see how many bits are exactly the same. So 8-bit, and 1, 2, 3, 4, 5. So 5. So 8 plus 8 plus 5 is equal to again /21.
Okay. That's normal. From there it is
yeah. So whatever range is, like the range of prefixes that is given to you, convert all those ranges into binary and find out the network ID based on the same. And whatever part is common, find out the number of bits that are common. Find out the number of bits that are common in all those prefixes and put it like slash, and then whatever number of bits were common in all the prefixes. So for example, here total 21 bits are common in all the prefixes, so slash 21. Similar to that, for example, here, like total 22 bits are common. So 8 plus 8 plus 6, so slash 22. Okay. So we don't want to perform the filtering. We do not want to perform the filtering based on, let's say, prefixes. I want to perform the filtering based on this gateway. I want that I should not receive any prefix from that particular next hop. So from router EIGRP point of view, there are two gateways. If I go to router number FA 0 by 0, so this is FA 0 by 0, this is FA 0 by 1, right? So this is FA 0 by 0 and this is FA 0 by 1. So I am receiving the prefixes from two path, and I don't want to receive the prefixes from one of the gateway. Like this is my gateway, this is my gateway. I don't want to receive from one of them. I want that all the prefixes should be received from this gateway only, or maybe from this gateway only. I want to block all the prefixes from other gateways. I want that router number 12 should install the route in the routing table only from this gateway. It should not accept like any other route from any other gateway. So we can also use the prefix list as a gateway filter list. So IP prefix list, same, maybe name Cisco. Then you need to permit what gateway exactly. This gateway I want to permit. So write down this as like this. And IP prefix list, Cisco, deny everything else. So this prefix list that I have configured, the purpose of this prefix list is not to match the prefixes based on the IP address, but to match the prefixes based on the gateway. So I am receiving all the prefixes on router number 12. I am receiving all the prefixes on router number 12 from this and from this, and I do not want to receive the prefixes from anywhere other than this 100.1 subnet. So I have configured the prefix list called Cisco permit, and then here we have specified that gateway that I wish to receive the prefixes from, and here the rest of the things. And I'm going to say router EIGRP 100 and distribute list. This time I'm going to mention the keyword gateway. Distribute list gateway, and eventually we are going to use the prefix list anyway. So distribute list gateway, and then the name of the prefix list that we have configured in out and all that. So if you have like multiple exit points, you can specify that I do not want to advertise the prefixes from this gateway, but from this gateway only. So in out direction, it can also be applied. Otherwise, you can just do it like that. So distribute list gateway keyword, not the prefix keyword. If you use the prefix keyword, it is going to filter the prefixes based on the IP address and mask. And if you use the gateway keyword, that means the prefix list will be used as the gateway filter list. This is what we refer to as the gateway filter list. So IP route EIGRP, you might see that all the prefixes you are now receiving only from one path, not from the other path. So looks like the gateway filter list is working perfectly. So from whatever gateway you want to allow the prefixes, match them in the prefix list, and rest block every other of them, and then you can just call it in the EIGRP OSPF. You can filter the prefixes based on the gateway as well. So we can use the prefix list as the gateway filter list as well. We can use the prefix list to perform the route filtering normally, and we can also use the prefix list as the gateway filter list. The prefix list can be used to filter the prefixes based on the gateway IP address as well. Also, we can mix both of them. We can mix both of them here. So then prefix list, match the prefixes, distribute list, prefix list, show IP prefix list. If you do not specify the greater than equal to, then exact matching will happen. If you have specified only greater than equal to, then greater than equal to. If you have specified only less than equal to, then less than equal to. And if you have specified both, then the certain range will be matched. Okay. So editing can be done as well by mentioning the sequence number as per the requirement. We can mention IP prefix list CCNP. We can mention the sequence number to add a statement before or after a particular statement. If you want to match a given range, then again, similar to that, we can match a given range as well. We needed to match this range. We found out that, okay, to match this range, the IP address and subnet mask will be this one. So we have written that down. Then greater than equal to less than equal to we have specified. So this is done. Here we can use the gateway one as well. IP prefix list, the name of the prefix list, then deny, then the gateway IP from where we want to filter, and then permit everything else, and then apply it in the page. We can use both at the same time, do it yourself. We can use both at the same time as well. For example, I want to permit these prefixes only from this gateway. I want to allow only these prefixes from this gateway. So create a prefix list that matches your prefixes and create a prefix list that matches your gateway and call both of them. Command is distribute list prefix that I want to filter these prefixes from this gateway only. Instead of using in out, we can use the keyword gateway in and out. So we can use both at the same time as well. We can use both at the same time as well. We can use like access list that filters the route and the access list that filters the gateway both at the same time as well. IP prefix list, the name of the prefix list, then the range, and then greater than equal to, less than equal to, and then the IP prefix list, the name, and then permit that the gateway. And we have called both of them in the statement. So this statement says, I want to filter, I want to, as per this statement, I want to receive these prefixes only from this gateway. From everywhere else, block it. So we can use both at the same time. Prefix list can be used as the gateway filter list as well. Prefix list can be used to perform the route filtering based on the IP address, subnet mask, and range. Prefix list can also be used. Prefix list can also be used to perform the filtering based on the gateway. Right. These slides are available actually on the same portal. You can find that out from there. Okay. Now, prefix list can also be used. Prefix list can route filtering is not part of our CCIE content actually. That's why they are not there. Yeah, like what I can do, I will upload these in the portal only. Like it will not be there in the the hard copy that you have. It is not part of, so like these things, the like route filtering is not part of specifically the CCIE content. It is part of CCNP actually. So these slides specifically belong to the CCNP. But since we need to discuss the route map, like we are going to discuss the BGP, so you should aware of like these. So it's more like a revision thing that we are doing. I will upload these slides on the portal. You can have it from there for a reference. And you can also see that the topology is quite different here because this is topology from the CCNP, not from the CCIE. So this topic is specifically belongs to the CCNP, not the CCIE. So that is why you might not have in the handout. But anyway, I will upload it. Now, the prefix list can also be used in specifically OSPF to filter the LSA. In OSPF, remember that we cannot filter the LSA. We did the route filtering on router 3, but as we have discussed in the last class as well, that route filtering techniques such as access list, such as prefix list, these route filtering techniques such as access list, prefix list, they are only and only going to filter the routes. And in OSPF, LSAs are exchanged. So we saw that in the last class that this router was not having the route, this router was not having the route, but these routers, they were having full routes in the routing table. Because when the router 3, when we perform the route filtering on router 3 and router 4, based on the access list, prefix list, the LSAs still get exchanged to the router number 5, to router number 6, to router number 1, to router number 2, and based on that, the information was getting there on 1 and 2 and 5 and 6. So I want to filter the LSA. If you want to filter the LSA, you have the options of that stub, totally stub, NSSA, totally NSSA. You can change the type of area, and by doing that, you can filter the LSAs. Second, we can use the distribute list. We can use the distribute list to filter the LSAs only on ASBR. Like if on router number 8, let's go on router number 8, and I want that this router show IP OSPF database. I want that this router should not advertise all of these type 7 LSAs. I do not want this router to advertise all these prefixes. I don't want that to happen. I want this router to only advertise 4, 5, 6, 7. I want that this router should not advertise these prefixes. I can use the access list, like access list 90 and deny 130.1.0.0, 0.0.3.255, access list 90, permit any, access list 90, permit any, then router, OSPF, distribute list, 90 out. We can do that. Remember that distribute list in out direction does not work on OSPF, because distribute list is going to filter the routes, and in OSPF, LSAs are exchanged. So distribute list does not work in the out direction in case of OSPF, except for ASBR. If we apply this distribute list in out direction on ASBR, it is in fact going to do show IP OSPF database. It is going to in fact filter. It is going to filter the LSAs. It is going to filter the LSAs. We do not have the LSAs now. Distribute list, using the prefix list, using the access list to perform the route filtering, using the like access list and prefix list to perform the route filtering in out direction does not work in OSPF, because distribute list is going to filter. Distribute list is going to advertise. It is going to filter only the routes. It does not take any action on the LSAs. But if we apply the same distribute list in ASBR, that distribute list is going to filter the LSAs. Otherwise, distribute list is not going to filter the link state advertisement. Distribute list can only filter the routes. Exception, ASBR. Now, what we want to do here, we want to achieve the similar thing on ABR. This is how we can filter the type 5 or type 7 LSAs from being generated using the distribute list on the ASBR. We want to achieve the same kind of thing on the ABRs as well. I want that this router, which is, let's say, for example, router 1, I want the router that is router 9. I want these routers must not advertise that 9.9 subnet to the neighbor router. This is area about a router, this is area about a router, this is area about a router, this is area about a router. I can use a concept called area filter list. Area filter list in OSPF. There is a concept called area filter list in OSPF. The area filter list in OSPF can filter the LSAs. Area filter list in OSPF can filter the LSAs, specifically speaking, type 3 LSAs. Area filter list. Area filter list can be applied. Area filter list can be used in OSPF to filter the type 3 LSAs. Eventually, the area filter list is going to use the prefix list again. So nothing different. So prefix list. Area filter list in OSPF is going to filter the type 3 LSAs. And again, area filter list is going to use in backend. It is in fact going to use the prefix list for its working. Okay. So what I want to do, I want this router number 1. I want this router number 1 to advertise only 9.9 subnets to the neighbor router. I want this router number 2 to advertise only 9.9 subnet to the neighbor router. I want this router 1 and router 2 to advertise only 9.9 subnet to the neighbor router. How can I do that? I can go to router number 1. First of all, I'm going to create a prefix list. In that prefix list, I am going to match only these 9.9 subnets. I'm going to match only these 9.9 subnet. How can I do that? Configure terminal, IP prefix list, ABCD, whatever name you want to specify, then match 9.9.0 slash 22, slash 20 slash 30. So you want to match 0, 1, 2, 3. So the CIDR is going to be slash 30. So convert the bits into the binary and find out how many bits are exactly the same. You will find that 30 bits are exactly the same. So 9.9.0.0 slash 30 and less than equal to, since everything is on slash 32. So greater than equal to 32, less than equal to 32. So I have configured a prefix list called ABCD. There I have matched permitted 9.9.0.0 slash 30 range. I have allowed the prefixes from this range that are coming on the CIDR slash 32 less than 32. So all these prefixes are on slash 32. So I have matched all that. Okay. And rest everything, of course, is going to be denied. So you don't need to mention it, but other than that, everything is going to be denied. And then once you have configured the prefix list, use the keyword router OSPF and area. Command is area. Area, now understand this. Area 3 filter list. ABCD, filter list, prefix ABCD, and then again in or out. So currently on router number 1, we have 3 area. On router number 1, this is router 1, we have area 3, we have area 0, and we have area 1. If I write this command says area 3 filter list prefix out. What does it mean? It means that on router 1, when the prefixes are being advertised out of the area 3, then the filtering will take place. Area 3 out means when the router 1 is generating the type 3 LSAs of these prefixes and advertising it out of that area in area 1 and area 0, then we are going to perform that filtering. This command means I do not want to advertise any other prefixes than these prefixes into both area 1 and area 0. This command basically means that from area 3, I am not going to advertise the prefixes to area 1 and area 2. Area 3 out means that from area 3, these prefixes are not going to be sent out in any other area. Area 3 out means like area 3 out direction. We have applied that prefix list. So those prefixes are not going to be available in either area 0 or area 1. So area 3 filter list and out. And make sure that you use the same commands on the second ABR as well, because otherwise the other ABR will keep advertising those prefixes. So I'm going to use the same command here as well on this area border router. So command is IP prefix list, name of the prefix list, then either permit or deny statement, whatever you wish to specify, and then router OSPF, then area 3 filter list, and then in and out. Right? This command means that if a router has multiple area, such as router 1 has area 3, area 1 and area 0, the prefixes will not be sent out of the area 3. And you check, you go on router 3 maybe, and you check show IP route OSPF, and you see that you have 9.9 subnets only. Where is that 11 subnet? Show IP route OSPF, pipe include 11, 11, 11, 11. You don't have that. Where is that 10.10.10 subnet, 9.9.9 subnet? You do not have any of those prefixes. Like of this area, from this area, only 9.9 subnets are allowed to go in area 0 and area 1. So I issued this command that says that on router number 2 and on router number 1, I use this command, prefix list, name of the prefix list, then what prefixes we want to permit, and then what prefixes we want to deny. And the area out means the prefixes when they are sent out of the area. When the prefixes are sent out of this area, the filtering will take place. Area 3 filter list prefix out. But maybe we don't want to perform the filtering in this manner. Maybe I don't want to perform the filtering for both the area. I only want to perform the filtering in area 1. So I could have used the same keyword. I could have used the keyword instead of using this. I will remove this and I'm going to use the keyword area 1 filter list prefix ABCD in. It means that now when the prefixes enter in the area number 1, then the filtering will take place. Area 1 in means that the prefixes will be filtered specifically for area 1. They are not going to be filtered for the rest of the area. So I could have also used the filtering in this manner, where the filtering will take place, where the filtering will happen for one specific area, not for all the areas. So area 1 filter list prefix, and then the name, and then in we can use this statement as well. This command will only do the filtering on type 3 LSAs. That means rest all the things will be received as it is. Yes, so 120, 130, all the subnets will be there as it is. So now you check on the router 3. You check on the router 3. You see on the router 3, we still don't have 9. We still don't have 11. But if you go on, let's say, for example, router 1, you can find out show IP OSPF database. You can see that in area 0, still all the prefixes are getting advertised. So the filtering did not take place in area 0. The filtering only took place in area number 1. So area filter list here, prefix list can also be used as the area filter list. Because in OSPF, distribute list will not work in the out direction as it is used to filter the routes, and OSPF exchanges the LSA. The exception is ASBR. So in OSPF, the devices, they exchange the LSAs, they execute the SPF, they calculate the route and they install the route in the routing table. And right here, the distribute list is applied. But devices have already exchanged the LSA. To every device can individually execute the SPF respectively. So if you do the filtering on router number 2, router number 1 and router number 3, they will still have the route. So distribute list does not work in out direction in case of OSPF, exception ASPR. So we can use this thing called area filter list. This is our this area filter list can filter type 3 LSAs based on the prefix list again. It can only be applied on area border router because ABR is the only device that generates the type 3 LSA. So for example, there is a subnet 111 that I do not want to advertise only and only in area 0, but I want that subnet to get advertised in area 2. So what command I'm going to use? I'm going to use the command on ABR, area 0 filter list, whatever name, and in. That means when the prefixes enter the area 0, filtering will take place and the subnets are going to be blocked respectively. The filtering will not take place in this area because we did not use the command for that area. Similarly, we have a subnet called 12, which I don't wish to advertise either in this area or this area. So what I have used the command, I have used the command area 2 filter list out. That means when this area border router advertises the prefixes of this area out into the other area, first of all, it is going to apply the filtering. And as per the filtering, it is not even going to advertise these prefixes out either in this area or in this area. So direction here in the area filter list, direction here in the area filter list is based on area itself, not based on the interface. Okay. Area filter list. Area filter. You can use this to filter type TLSs applicable only on ABR. A prefix list again is going to be used for the same purpose. So use the prefix list, match your desired prefixes that you want to block and permit, and then apply it respectively onto the OSPF speaking router. So as you can see that prefix list has a lot of use cases. Prefix list has its use cases, but prefix list can be used to filter the route. Prefix list can be used to filter the LSAs. Prefix list can be used to filter the gateways. Like we have different use cases of the prefix list, but we do not still have here the option to match any two random IPs. We do not have the option to match even odd. We don't have those options actually. So it has its limitation as well. It has its advantages based on whichever, like, do you want to perform the filtering based on even number, odd number, two random IPs and all, you can go for the ACL. If you want to perform the filtering based on the CIDR, you can go for the area filter. You can go for the prefix list. This is for this thing that we are talking about. This is for filtering. Again, this is for filtering. This is for filtering. This is not for like path manipulation. This is just for filtering. So the prefixes are going to be filtered. The prefixes are going to be filtered, and the prefixes that are basically getting filtered, they will not be available in the routing table. So if the other path goes down, you still will not see these prefixes in the routing table. Fine. So access list, standard, extended, prefix list, normal prefix list, we have to perform the filtering. Any doubts if you have, you can ask, let me know. All these options are available on all the protocols. All of these options are available in all of these protocols. All of these options are available in all of the protocols, REP, EIGRP, and OSPF as well. Any doubts so far, let me know. Okay. Now, another way to do the same, another way to have some sort of path manipulation and route filtering is called offset list. Offset list. Offset means metric. So just another way of saying metric list. Remember that this might not be available everywhere. Remember that this might not be available like in everywhere. So offset list we can use to tune. Offset list we can use to tune the metric value. And if you are, if you increase offset list, we can use to increase the metric value. And just in case, if you increase the metric value so much that it reaches to infinite, the route is going to be filtered. For example, in protocols such as RIP, you see here, let's go to router number 13. On router 13, I am receiving all these prefixes via RIP routing protocol. And again, I don't want to receive these prefixes maybe on this particular interface on FA0/0. All I can do, configure terminal, access list, 1 permit any, all the prefixes I have matched. I have matched all the prefixes. I want to increment the metric value of all the prefixes. So I have matched all the prefixes here. If you wanted to increment the metric value for specific prefixes, you could have done that for that one as well. And the command router rip command is offset list, the ACL, then in, then by how many hops you want to increment the metric. I want to increment the metric by 16 hop so that it gets filtered. And on what interface? On FA0/0. So this command means when you receive the prefixes on the interface FA0/0, if the prefixes belong to the ACL1, increment their metric value by 16. All the prefixes in the ACL1 will have 16 incremented in the metric if received on the interface FA0/0. In protocols such as RIP, it is possible to set the metric value to infinite. In protocols such as RIP, it is possible to set the metric value to infinite by using this offset list and incrementing the metric value to, let's say, 16. As you can see, do show IP route RIP, you don't have the route on the other interface now, because all the routes that are received onto that interface, they will have much more higher metric, and in RIP, maximum metric can be 16. So when the prefixes are getting advertised, they are getting advertised with the hop count value of 10 plus 16, the metric value goes to 26. So that's why they are not available. In protocols such as RIP, RIP uses hop count as a metric value and maximum hop count limit is 15. So we can increment the metric value to 16 for any prefix to make it unreachable, because the metric will be considered as infinite. So for example, we wanted to filter all these prefixes. So I have used this, I have used access control list to match these prefixes first of all, and then use the command offset list number 47. In or out means like incoming prefixes will, you want to increment the metric value, or you want to increment the metric value for outgoing prefixes, then by how many you want to increment the metric value, and then in what interface. It is possible in protocols such as RIP, it is possible in protocols such as RIP to set the metric value to infinite. It is possible in protocols such as RIP to set the metric value to infinite by setting the hop count value 16. However, this cannot be done for EIGRP. This cannot be done for OSPF. We cannot go in EIGRP. No. See, if you go to, let's say, router number 12. Okay, let's go to router number 12. Let me filter all these, filtering all these things that we have applied. Let's clear that. Now, let the information. Okay, now show IP route EIGRP. I have all the prefixes. Let's say I do not wish to receive any prefix onto this particular interface, and we are asked to filter these prefixes with the help of offset list. We actually cannot do that. We cannot do that. If you go to router number 12, access list 1 permit any, you have matched all the prefixes, then router EIGRP offset list all the prefixes that match in the ACL number 1, all the prefixes that are permitted in the ACL number 1, I want to increment their metric value. So offset list number 1 in, that means when the prefixes are received, I'm going to increment the metric value, and this is the maximum number that you can use to increment the metric value. If I write down 8 here, it will just not accept it. So the maximum number is this one. On which interface? On the interface FA 0/0. It doesn't matter actually. You do whatever you want to do. Even see, all the prefixes that were being received on the interface FA 0/0, they already had some metric value. And now the metric value will be incremented by this much. But still, you see, now on one interface, the metric is lower. On one interface, the metric is higher. So you have done path manipulation, but the filtering did not take place. You can see that. So IP route EIGRP, do show IP route EIGRP. You can say that, okay, I am receiving only one prefix, so might be that the prefix other subnets got filtered. The prefixes on this interface got filtered. That's not the case. Interface FA 0/1. If you shut it, it's down. Because since now you have incremented the metric value, since you have incremented the metric value on the other interface, this path will not be considered as the best path, but these routes are not filtered. And you can check it by shutting down the other interface. You can see do show IP route EIGRP, and you can see all those prefixes are still there. So in protocols such as EIGRP, it is actually not possible to set the metric value to infinite by using this offset list. By using this command, it is just not possible. Because if you are aware, classic EIGRP, 32-bit metric, 4.2 billion is the highest possible metric value. Named EIGRP, 64-bit metric value, 2 raised to the power 64 metric will be considered as infinite, which we cannot set. This is more like I think half of that limit that we have. So in the offset list, in the EIGRP, and in OSPF, in protocols such as OSPF, we don't even have the option of like configure terminal, router OSPF, offset list. We don't even have the option of offset list. Offset list is available in RIP and EIGRP protocol. In case of RIP, it can be used for path manipulation and route filtering. In case of EIGRP, it can only be used for the path manipulation. Somehow, if you can make the metric value go infinite in EIGRP, means somehow if you can increment the metric value so much that it reaches to this number or reaches to this number, then only that prefix is going to be filtered. Otherwise not. And this is not possible with the help of the offset list, because offset list gives you the number maximum to maximum decimal, which is nowhere near to 2 raised to the power 32, which is nowhere near to 2 raised to the power 64. So in EIGRP protocol, such as in OSPF, we don't even have the option of the offset list, because offset means metric, and in OSPF we can increment and decrement the metric directly on the interface. So we don't even have the option of offset list. Offset means metric, and metric can be incremented, decremented directly on the interface in OSPF. No need to use offset list for the same purpose. In EIGRP, the offset list can be used to influence which part becomes the best one. And you can use this offset list. You can use this offset list. Let's say this is a router 12. It is receiving same subnet on 2 paths. One path is successor, one path is feasible successor. You have adjusted the variance so that the unequal cost load balancing is taking place. But unequal cost load balancing is not taking place in the ratio that is expected, such as I told you a question that you need to perform the load balancing in 3:4 ratio, let's say, for example. So the load balancing is not happening in this ratio. So to influence, to basically do the load balancing in an appropriate ratio, we can also increment the metric value respectively here so that the load balancing takes place accordingly. Offset list can be used to influence the metric value, and since based on the metric value it is decided like how the load balancing can take place and equal cost load balancing can take place, so that can now also be achieved. Okay. Now, a question here that you need to find the answer yourself. In protocols such as RIP, when we use the offset list, it is going to adjust the hop count, because hop count is the metric value for rerouting protocol. In case of OSPF protocol, if we wanted to do the same, there is no option of the offset list because we can directly influence the cost under the interface. In both the condition, this hop count is a single numerical value. The cost is a single numerical value derived with the formula 100 upon bandwidth. There is no formula for this hop count, it is just hop count. The question is, in protocol EI-gRP, if you remember, we are using the offset list. We are using the offset list to influence the metric value. We are using the offset list to influence the metric value. I know that in EI-gRP, the metric value is a single numerical value. Completely fine, completely okay. But if you remember, this single numerical value that we get in EI-gRP as the metric value is calculated based on the parameter called bandwidth, load, delay, reliability, and MTU. So my question is, when we use the offset list to influence the metric value in EI-gRP, how does that work actually? In RIP, it works very simply by incrementing the hop count. Okay. In OSPF, we can go under the interface, decrement the cost. That is also okay. But in EI-gRP, the metric is not calculated based on one single value. It is calculated based on bandwidth, load, delay, reliability, MTU. Then we have metric calculation formula. In that formula, all these values are put, and then the result is the single numerical value which represents the metric. Now, let's say in EI-gRP, the question is, in EI-gRP, let's say for a subnet based on the bandwidth, load, delay, reliability, MTU, based on these metric component, let's say the metric was 1000. And now we have used the offset list to increment this metric value by 500. So now the resultant metric has become 1500. EI-gRP cannot just directly make the metric value to 1500 without changing the components. Remember that this metric can only be influenced by changing these components, which you have already done. You have already changed the bandwidth, you have already changed the delay, because these are the things that are used by default. Now the question is, when we use the offset list, to change the metric value administratively, which of these 5 components EI-gRP is going to change to influence so that it gets this result? Based on the metric calculation formula, the metric is this one. Now the metric has to be this one. So which component out of these 5 components will be changed by the EI-gRP so that this metric is achieved? Again, in EI-gRP, metric is calculated based on the metric calculation formula, which uses bandwidth, load, delay, reliability, and MTU components. So when we increment the metric value with the help of the offset list, actually, EI-gRP just cannot go and increment the metric value right away. It needs to actually change the components so that it gets the resultant metric that you desire. So which of these component or components are going to change to achieve this metric value? Let's say, for example, so which of these components are going to change? Okay, so maybe could be bandwidth, maybe could be delay, maybe could be load, reliability, MTU. You find that out yourself. But anyway, with the help of the offset list, it is also possible to set the metric value to either infinite or some particular value so that we can achieve primary, secondary thing. Any questions so far? Let me know. Okay. All of these tools that we have discussed so far, they are good. Like we can use the ACL, we can use named, numbered, standard, extended, prefix list, gateway filter list, area filter list. We can use like offset list. We can use these things to perform the route filtering to influence the best path and all. We can use all these tools. We can use all these techniques for the same. Again, these tools have the limitation. These techniques have the limitation. For example, the access list can only filter the prefixes based on prefix. The prefix length can only filter the prefixes based on prefix length. Offset list can do the filtering based on the metric. Maybe you need to perform the route filtering based on the criteria that your ACL and prefix list cannot just match. Maybe we want to do the route filtering based on certain criteria that you cannot actually match. In the ACL or the prefix list. Such as, for example, remember that when we redistributed our EIGRP prefixes into OSPF, we added a tag value so that those prefixes can be easily identified in the OSPF domain. Remember that when we redistributed the RIP prefixes into OSPF, we added a tag value so that those prefixes can be identified in the OSPF domain. And now a certain requirement has come that says filter all the prefixes from the RIP routing domain on router 3 and router 4, that I don't want to receive the prefixes that I was receiving from this partner site anymore. So I know that all the prefixes that are coming from this partner site, they have the tag value of 100. So I want to use that tag to perform the route filtering. Maybe I want that in my routing table, if I have the metric from here to here, I will filter all those routes. Maybe I want to filter the external routes. Maybe I want to filter internal route. Maybe I want to filter all the routes that I have received onto this interface. Maybe we want to do some more robust filtering that is just simply not possible with the help of the access list or with the help of the prefix list. So if you want to use that, if you want to use some more robust way to perform the route filtering path manipulation, you can always go for our next and the final technique to perform the route filtering path manipulation, route map. We can use the route map. We can use the route map to perform path manipulation, route filtering in much more robust way than the access control list and prefix list. For example, on router 3, I am receiving all the prefixes. On router 3, I am receiving all the prefixes. Let me just remove everything that we have configured so far. As you can see here, on router number 3, I am receiving all the prefixes. Show IP, route OSPF. Okay. I don't want any prefix in my routing table that has the metric value of 20. I don't want any route in my routing table that has the metric value of 20. How are we going to do that? I do not want to have any route in my routing table that has the metric value of 20. Okay. I do not want to have any route in the routing table that has the metric value of 20. Okay. How can we do that? With the help of access list, find out all the prefixes that are coming with the metric value of 20 and filter them with the help of the ACL. Access list 1, deny this, deny this, deny rest of the subnets, and you can do the filtering one by one. Later on, the situation arrives where you need to filter the prefixes that have the metric value of 19 as well. Then edit that ACL and deny these ones as well. Or configure terminal, route map, ABCD, deny, sequence number. Don't add the sequence number. Sequence number will be incremented by 1010 again. So route map ABCD, deny, sequence number 10. And I want to deny all the prefixes that match the metric. I want to deny all the prefixes. The statement route map ABCD deny 10. This is the statement. Route map ABCD deny 10. Match metric. I want to match all the prefixes that has the metric value of 20 and I want to deny them. And apart from that, everything else is allowed. Permit sequence number 20. Don't write down anything here. That means permit anything, permit everything. If you have not written down any match criteria, that means like permit everything. Done. One statement that says route map. The name of the route map is ABCD. This is the deny statement that I am going to deny the prefixes that have the metric value of 20. This statement says route map ABCD, deny sequence number 10 and match metric 20. So all the as per this statement, all the prefixes that have the metric value of 20, they will be denied. And all the prefixes that don't have the metric value of 20, they will be looked up in the next statement. And in the next statement, we have said permit everything else. So now you check configure terminal, router OSPF, distribute list, route map, and ABCD in. Distribute list, route map, and ABCD in. So this is how we can apply the route map, again with the help of the distribute list. If you want to apply the access list, then also the distribute list. If you want to apply the prefix list, then also the distribute list. If you want to apply the route map, then also the distribute list. So distribute list, name of the route map. So route map name was ABCD and then the direction. So this command basically says that I'm going to filter all the prefixes with this route map. In means inbound direction. So when the prefixes are received on this router, the route filtering will happen based on the route map. And the route map says that if the prefix has the metric value of 20, I am going to block it. And if the prefix does not have the metric value of 20, next statement will be looked up. And based on the next statement, everything else is permitted. So do show IP route OSPF. In your entire routing table, you should not have any prefix with the metric value of 20. You can check it by the keyword pipe include 20 /20. No prefix with the metric value of /20. That's it. Route map is a tool. Route map is a concept. Route map is a tool that we can use to match the prefixes based on the criteria that your typical ACL or prefix list cannot match. Things such as metric, things such as tag, things such as like a lot of other things. And it is very easy to edit the route map. Now let's say, for example, I want to permit only the prefixes with the metric value of 20, and I want to block everything other than that. So you don't need to write down the entire route map. You just need to say route map permit 10 and route map deny 20. Done. You don't need to write down all the statements again. No need to write down all this. You just said, now earlier this was denied, now you changed it to permit, and it was permit, you just changed it to, you don't need to write down each and everything again and again. You don't need to do that. Now you can see the show route map, those statements are still as it is. See, the match metric and all these things, these are still as it is. Editing the route map is very easy. If you want to change the from permit to deny, just use the keyword like route map ABCD permit 10 or deny 20, whatever. Changes can be done respectively. And now you check show IP route OSPF, and you only have the prefixes that have the metric value of 20. So the point is we can do the filtering, we can change the, we can do show run pipe section router OSPF. We can apply this route map exactly in a similar way as we have applied the access list and the prefix list. And in the route map, I can specify the conditions. Route map ABCD, permit the prefixes that have the metric value of 20 and deny everything else. Like you can change this permit to deny to permit just by using the normal statements. You don't need to write down the entire route map or delete the entire route map again. Also remember that if we have not created the route map, but the route map is still applied, that is a problem. It was not a problem in the access list. It was not a problem in the EIGRP, the prefix list. But in route map, it is a problem. If you have applied a route map, that route map must exist. That route map must exist. Because if you have applied the route map and that route map does not exist, you will see you don't have any route. It's like do show route map. It's like we have the route map with 0 statements. We have a route map with no statement, which is explicitly going to block everything. If in case of access list, if we did not configure the ACL, but it was still applied, no problem. If it was prefix list, we did not configure the prefix list, but we applied first, no problem, but not in case of route map. If the route map does not exist and you have applied that route map, the prefixes are going to be filtered. All the prefixes are going to be filtered. So you have to be very careful. So route map, ABCD, permit 10, and these are like some of the things that this route map can do filtering based on. These are a few things that based on this route map can perform the matching of the prefixes. If I remember on router number 11, if I go, show run pipe section router OSPF. So when in router OSPF, when I am redistributing EIGRP prefixes, I am going to add the tag value of 200. This command means that when in OSPF, you redistribute EIGRP prefixes, add a route tag value of 200. And now I can go on, let's say, for example, router number 3, and I can say, I want to block all the prefixes, or I want to permit all the prefixes, only those that have the tag value of 200. Route map, name of the route map, then permit, then sequence number, then match tag, and like route map, ABCD, and even if you do not specify the deny statement, it is there. Even if you don't specify this, it is there. So you can check, show route map, show route map. This route map has only one statement. And as per this statement, I'm going to permit all the prefixes that have the tag value of 200, and all the prefixes that don't have the tag value of 200, those will be looked up in the next statement. And since we did not specify the next statement, block. So you check to IP route OSPF, you will have only those prefixes that have the tag value of 200, 120, these prefixes only. Maybe like let's go to router number 8. On router 8 as well, show run pipe section router OSPF. When you redistribute the RIP prefixes into OSPF, add a tag value of 2000 maybe. So all the RIP prefixes, all the RIP prefixes, when they get redistributed into the OSPF, they will have now a tag value of 2000. And I can go on router number 3, and I want to now allow those prefixes as well. I don't need to write down. I just can say configure terminal, route map, ABCD, permit 20, match, tag 2000. Second statement says that I am going to permit all the prefixes that have the tag value of 2000. And check, do show IP route OSPF. You have 120. And once the redistribution takes place again, like you will have the 130 subnets as well. It might take some time, but that will happen. So otherwise you can just say clear IP OSPF process. So router 8, like the RIP prefixes, when they get advertised again, they will have the tag value of 2000, and those prefixes are also going to be allowed now here, because here we now said all the prefixes that have the tag value of 200, they are permitted, and all the prefixes that have the tag value of 2000, they are also permitted, and everything else is blocked. Route map can match on the criteria that your typical access control list cannot match. Criteria such as, for example, tag, criteria such as, for example, route type, criteria such as, for example, interface, IP, and a lot of other criteria as well. It is much more robust tool than the access list prefix list to perform the route filtering on the devices. We'll see more of this later on, but just to give you the idea that the route map can perform the filtering based on the criteria that your typical access control list or the route map cannot just match. Yes, Devashi, I think like you had a question.
Yes, actually you told that if there is no route map present, it will block everything, right?
Yes, yes.
Means we cannot see any route. Means there is no route.
Of course, like if you have, for example, you have applied a route map here, but that route map does not exist. Like maybe you have deleted it. If that route map does not exist, it will be considered as, you can think it like a route map with 0 statements, a route map with no statements, and that will be filtered actually. So it will filter all the routes. Do show IP route OSPF, you will not have anything.
Okay.
Which is not a condition in case of access list and prefix list. In access list and prefix list, this does not happen. In ACL and prefix list, if you have not created it, but you have applied it, so like it will just work fine, but it will not work fine in case of like route map.
Okay.
So why I'm telling you this, because what happens generally, sometimes what happens that in your exam, like they might, let's say for example, configure they might configure, let's say for example, the route map, something like this. They say like route map, they say configure route map and Cisco, and then permit and whatever they want to permit, right? And then route map Cisco deny 20, and when they apply that, they apply this right there, route map, sorry, distribute list route map, and they apply like that, and uh, you will not be able to find out the difference in between these two. What is the difference in between these two? Can you see? What is the
there is
difference in between? Yeah. So this is the route map that is created, but this is the route map that is applied. There is a difference in between these two.
that is Cisco, and here is the
Zero.
name. Yeah,
This is
0.
zero. This is not O anymore. This is zero. This is zero. So
Yeah.
this and this is different now. You will not have any route in the routing table. You can check. The name of the route map must match exactly. Otherwise, it will just not work. Name of the route map must match exactly. Otherwise, it will not. They also do like this. Like they say, like router, they create a route map, right? Like that. Route map, CCIE, and permit and whatever. And then when they apply router OSPF, they say route map, distribute list, and then they say route map, then say CC1E, and you will not be able to see, you will not be able to find out the differences. So the point is that the route map, you must remember that in this situation, the name of the route map must exactly match here in the distribute list, and that is why it's always recommended that you always, copy and paste. You always copy and paste these statements. You always do copy paste in case of route map. In fact, you should copy paste the names anywhere, like from all the places. You should not actually do you should not actually write down the statements one by one. You should practice the copy paste, like copy and paste the naming specifically. So yeah, that statement remains valid, that if you have not configured the route map, but you have applied it, it will be a problem. Fine. So we'll continue from here tomorrow. We will talk more about the route map in the next class. In next class, we'll finish the route map and the use cases of the route map. So in last class, we saw very basic use of route map, where we saw that we can block the prefixes based on maybe metric, just in case if you want to, the route map. Let's see like more use cases of the route map. Let's see how we can do like route filtering using some other criteria as well. So let's see the other use cases of the route map. Let's go on again some routers and do route filtering again based on the route map. So let's say for example on router number 11, and let's cross check first of all that how we are doing the redistribution from EIGRP into OSPF. So if I go to router number 11 and I check on router number 11, show run pipe section router router OSPF, okay, that is done. Show run pipe section router EIGRP is done, okay. So as you can see that on router number 11, what we are doing, we are redistributing EIGRP prefixes. And when we are redistributing EIGRP prefixes, I am adding the tag value of 200. Similar to that, if I go to router number 8, on router number 8, I can see the same as well. Show run pipe section router OSPF, we can see that I am redistributing RIP prefixes, including the subnets, and I am adding the tag value of 2000. That means when the EIGRP prefixes get redistributed into OSPF, the tag 200 will be added. And when the OSPF prefixes get redistributed here, the tag 2000 will be added. So if I go to any router such as router number 3 and I see show IP route OSPF pipe include 120 subnets. So I am receiving all these 120 prefixes and I am receiving all these 130 prefixes. If I open any 120 subnet, 120.1.1.0, you can see the tag value 200 is there. And if you open any 130 subnet, you will notice that the tag value 2000 is basically there. So basically we are receiving the prefixes on router number 3 and the prefixes are having a particular tag value. This tag value, what we have done, when we perform the redistribution, we added this tag value so that we can identify that, okay, what prefixes are getting redistributed from where exactly. So, based on that, I can say that These prefixes are actually EIGRP prefixes. These prefixes are OSP, RIP prefixes. Because when the EIGRP prefixes got redistributed, the tag 200 was added. When the RIP prefixes got redistributed, then the tag value 2000 was added. Now again, the requirement has come. The requirement that we have here now, the requirement has come that we need to filter. The requirement has come that we need to filter all the prefixes. We need to filter all the prefixes with the tag value of 200. We have a requirement now that we do not want to receive any of the EIGRP prefixes in our routing table. I want that the partner site EIGRP, I was receiving all the prefixes from EIGRP domain into the OSPF. Now the requirement has come that I don't want. I want to filter. I want to filter all the EIGRP prefixes. I want to filter all the EIGRP prefixes from my routing table. I want that in router OSPF domain on router number 3. Any prefix that gets redistributed from EIGRP should not be available here. Okay. So what I'm going to do, what I can do here, I can go on router number 3 and I can again use the concept of route map. Either what you can do, either you can find all the prefixes that have the tag value of 200, show IP route, OSPF, pipe include, show IP OSPF, show IP route OSPF, and pipe include 120. Either what you can do, you can find all the prefixes that got redistributed from EIGRP, match them in access control list or prefix list, and then block them. Otherwise, what you can do, you can see like what prefixes are coming with the tag value 200, and then somehow match that tag and block the prefixes. So things such as route map, configure terminal, things such as this route map concept that we have here, it actually allows us route map, Cisco, deny, 10, match, tag, 200, just like that. I can just create a route map statement. I have created a route map, name of the route map is Cisco, and this is a sequence number. If you do not specify the sequence number will be incremented 10 by 10. But here we have specified the sequence number. And what do we actually want to do? We want to deny the prefixes. So route map, name of the route map, deny 10. This is the name of the route map. This is either permit or deny statement. So either you want to permit or deny. So deny 10. And then what do you want to do? You want to match the prefixes that have the tag value of 200. So this statement basically says all the prefixes that have the tag value of 200. This says that all the prefixes that have the tag value of 200, deny all those prefixes. Deny, block all those prefixes that have the tag value of 200, and apart from that, all the other prefixes permit them. Permit 20. Permit 20 basically means like match, like we have not specified any match statement. That means it means match all. That means it is going to match everything, and then it is going to permit it. So as simple as like you don't need to check the entire routing table, find out what prefixes got redistributed from EIGRP. You don't need to do that. While performing the redistribution, you already have added tag value 200 in all the prefixes that gets redistributed from EIGRP into OSPF. And now you can just simply use that tag value to perform the filtering. I said that I'm going to deny all these prefixes that have the tag value of 200. And any prefix that does not has the tag value of 200, for that, take a look at the next statement. And as per the next statement, permit everything else. Since we did not specify any match criteria, that means permit everything else. And that's it. Go under router OSPF, distribute list, route map, the name of the route map, and then in. It means like when the router installs the routes in its own routing table, when the router receives the LSAs, it executes the SPF algorithm on those LSAs and installs the routes in the routing table. Before installing the route in the routing table, it will apply this route map filter. And based on this route map filter, it is going to filter the prefixes with the tag value of 200, and it is going to allow everything else. So show IP route OSPF, pipe include 120, those prefixes are no longer there. But if you say pipe include 130, these prefixes are still there. So I can match the prefixes based on the tag and then either block it, permit it. I could have said that allow only those prefixes that have a tag value of 200. So all I need to do is to just go here and instead of deny, just say permit and deny everything else. So deny 20, like deny 20. So it's that easy to edit the route map. We can just change the statement deny to permit, permit to deny, and it will make the impact right away. Do show IP route OSPF. Now you can see only those prefixes that have the tag value of 200, they are in the routing table. All the other prefixes got filtered. So it's that easy. Like it's that easy to apply the route map. It is that easy to apply the route map. It is that easy to edit the route map as per the requirement. This statement, these statements that we have configured here, as per this statement, the entire routing table will be checked, and in the entire routing table, whatever prefixes are coming with the tag value of 200, they will be allowed, and rest all the prefixes are going to be blocked. That is what we mean by this statement. And also remember, we have already talked about that. Just in case, if you remove this route map, but this route map is still applied in the routing table, in the routing protocol, basically. So do show IP route OSPF, you will not see any prefixes because you removed the route map statement, but you did not actually remove it from the OSPF configuration. That means the prefixes are going to be filtered. So that which is not the case with the access list, which is not the case with the prefix list, but it is the case with the route map. Okay. Now, let's say I want to block the prefixes that have the tag value of 200 and the tag value of 2000. I want to filter all those prefixes. So how I could have written down the route map? I could have said like route map, whatever name of the route map. Then you want to deny. I want to deny the prefixes that have the tag value match tag 200. So I said in this statement I said. As per this statement, I'm going to block all the prefixes that have the tag value of 200, and whatever prefixes they don't have the tag value of 200, look up the next statement. The next statement says route map ABCD deny 20 match tag 2000. So in the second statement, I said that all the prefixes that have the tag value of 2000, they are also going to be blocked. And in the third statement, route map ABCD, I will say permit everything else. So I can keep increasing the statements in the route map. I can say like this first statement says match and block all the prefixes that have the tag value of 200. The second statement says match and block all the prefixes that have the tag value of 2000. The third statement says match and permit all the prefixes that have the tag value, like all the remaining prefixes that don't have the tag value 200 or 2000, match and permit all the remaining prefixes. And similar to that, router OSPF, I'm going to apply this distribute list route map A, B, C, D, and N. Similar to that, I'm going to apply this route map again. So we can have like more than 2 statements in the route map as well. It's not necessarily that you will have to have only 2 statements. We can have more than 2 statements. The first statement says match and block all the prefixes that have the tag value of 200. Then second statement says deny. Second statement says deny. That means like match and deny all the prefixes that have the tag value of 2000. And third statement says that whatever prefixes don't have the tag value 200, 2000, allow all the rest of the prefixes. That's what we mean by this third statement. And then we have applied that route map. We have applied that route map under the distribute list command here. So we can see to IP route OSPF pipe include 120. Those prefixes are not there, and 130, those prefixes are also not there. So we can actually, again, same, we can actually filter the prefixes based on this tag value. We can filter like prefixes that have the tag value 200, that have the tag value 2000, and permit everything else. We can use this tag match tag criteria so that, we can do the filtering based on the same. Now, what is the advantage of this? Like how, why, we are doing this? Because remember, there are very good chances, let's say, for example, in this topology, let's say we connect these 2 devices as well. Like, let's say we have connected this 12 and 13 router. Let's say these 2 routers are connected as well. So what can happen? And here we are also running, let's say, protocols such as either RIP or whatever, EIGRP doesn't matter. So there are chances that these prefixes, 120 prefixes that got redistributed from EIGRP into OSPF, They will go all the way to router 8. On router 8, they will get redistributed. From here, it will be advertised all the way to router number 12 as well, causing a routing loop. So I want that whatever prefixes I have advertised in the OSPF, I do not want those prefixes to get reverse advertised into the routing protocol. So what I can do while doing the route redistribution from EIGRP into OSPF, I can add a tag value, and while from here, when performing the redistribution from OSPF into RIP, I can block all those prefixes that have that particular tag value. You can see that it's not like we can only call the this route map in the distribute list command. It's not like that. I can go on, let's say, for example, router number 8, and I can see that router number 8 is performing the redistribution. If you go to router number 8, show run pipe section router RIP, you can see that here you can see that OSPF prefixes are getting redistributed into RIP routing protocol. What I want, and as a result, you can see, you go on router number 13, as a result, you can see show IP route RIP pipe include 120. You can see those 120 prefixes, 120.1.subnets. You can see those, all the prefixes. I think we have configured NSSA here. We need to remove the NSSA here. Then we will be able to see that. So this, I believe we have configured NSSA here. Yes. So let me remove the NSSA configurations on all the routers, router 6, router 7. Let me remove the NSSA configurations on all these routers. Let's remove the configurations of NSSA from all these routers. So this area is no longer the not so stubby area. This is just a regular area now. This is just a normal area now. As a result, if you go on router number 13, like all the prefixes, all the external prefixes, they will get redistributed. And like from router 11, they will get redistributed. They will be received all the way to area 2. And from there, they will get redistributed into RIP routing protocol as well. So if you go to router number 8 again and check the routes, show IP route RIP. Oh, sorry, you can go on router number 13 and check the routes directly. So you will receive 120 prefixes right here. You can see, you can confirm that you are receiving the 120 prefixes here, 120.1, 120.1.2, 3, 4, 5, all the prefixes you are receiving here. So what I want actually here, that all these prefixes, these 120 prefixes, all these 120 prefixes, they are getting redistributed from EIGRP to OSPF. They are being received by router number 8. If router 8 is advertising all those prefixes into router 13, and from there, those prefixes are getting advertised to router number 12, if there was a link connected to this one. So I want, like, if the router number 12 receives those prefixes, chances of loops might be there. So I want that router 8 should redistribute only and only OSPF prefixes into RIP routing domain. It should not redistribute these 120 prefixes into RIP routing domain. So I can just go on router number 8, and on router number 8, I can, similar to that, I can create a route map here as well. Route map, filter, deny, 10, match, tag, 200, and permit everything else. Same thing, same route map statement, same things you are going to configure here as well. Exactly same thing you are going to configure here as well. Like I have created a route map with the name of filter, and I'm going to block all the prefixes that have the tag value of 200, and I'm going to permit everything else. And then I'm going to go under the router RIP. I'm going to say redistribute OSPF 1, metric 1, whatever. And then right here, we can apply this thing called route map. At the time of route redistribution, it is also possible to apply the route map. Not only in the distribute list, it is also possible to apply the route map while performing the route redistribution. While performing the route redistribution, it is also possible to apply the route map. While performing the route redistribution, it is also possible to apply the route. This route map statement says that while I'm redistributing the OSPF prefixes into RIP, I'm going to filter the prefixes with this route map first. Like I am going to block, I'm not going to filter, I'm not going to basically, I am not going to advertise all those prefixes that have a tag value of 200 into RIP. And apart from that, I'm going to advertise all the remaining prefixes. So if you go here, you check now, you do not have actually any 120.1 subnet now. You do not have any 120.1 subnet now. All the prefixes that had that tag value, they got filtered. So if we have like again to repeat, if we have multiple redistributing points, we would want to control like what prefixes can get redistributed, what prefixes cannot get redistributed. We would want to control that. And one way of controlling that is to use the route map statement while performing the route redistribution. While performing the route redistribution, we can use the route map statement to control what can be redistributed, what cannot be redistributed. We can control that with the help of this route map statement. So on router number 8, I did create a route map. The name of the route map was filter. And as per this route map, I am going to block all the prefixes that have a tag value of 200, and I'm going to permit everything else. So once this route map gets applied in the route redistribution, once this route map gets applied in the route redistribution, you can see that router number 13 does not have those 120 prefixes. It has everything. This is also one use case of the route map. Like we can apply the route map in the route redistribution. We can apply the route map to perform the route filtering. Both of the options are actually possible. Any questions? If you have, let me know. Fine. Now, instead of writing down the commands like that, like you have written down the commands like that, you did not actually need to configure the route map statements like that. You actually did not need to do that. No route map A, B, C, D. So since you wanted to filter all the prefixes with the tag value of 200 and 2000, it was that easy. Route map, name of the route map, then deny, then match, tag, and then 200 and 2000. We can add it right here itself. We can add the tag values, like multiple tag values here. Like we can also, instead of writing down like two statements here, instead of writing down these two statements here, I could have written like match tag 200 and 2000. And all the rest of the prefixes are going to be permitted. So this statement, this route map statement basically says, that all the prefixes that have the tag value of 200 or 2000, if the prefix has a tag value of 200 or if the prefix has the tag value of 2000, it is going to be blocked, and rest all the prefixes are going to be allowed. Instead of writing down the commands like in two different statements, we can configure the commands in a single statement as well. We can configure it in one single statement as well. We can add multiple values here in the route map statement. So such as, for example, route map, name of the route map, then permit or deny, then the sequence number, then tag, like tag 200, 2000. It means that match and deny all the prefixes with the tag value of 200, match and deny all the prefixes with the tag value of 2000. And we have already applied that route map. We don't need to apply that again and again. This route map is already applied. Do show IP route OSPF 120, 130. You can notice that both of the prefixes are actually not paired. So this statement means, again, that this is a route map, name, permit or deny, sequence number, and then match tag this or this. Like if the prefix has the tag value of 200 or if the prefix has the tag value of 2000, it is going to be denied. And all the remaining prefixes are going to be permitted. So we don't have those prefixes, but we still have like all the remaining prefixes. All the remaining prefixes are still there. So we can create the route map statements like that as well. We can match multiple values from here. Not only multiple values, we can also match multiple criterias as well. I can say route map ABCD and ABCD deny 10, and I can say match. I can say match and for example metric. I can also say match metric. In the same statement, in the same deny statement, I am adding one more criteria for matching of the prefixes. In the same statement, I am adding one more criteria to match the prefixes. Match metric, and let me match the metric value. Let's say, for example, 19. So now I have added one more criteria. In the same statement, I have added two criteria. One criteria is tag and the other criteria is metric. We have added two criteria to perform the matching now. So what does this mean actually? It means that this route map ABCD statement number 10, sequence number 10 statement, it is going to block the prefixes that have the tag value of 200 or the tag value of 2000 and the metric value 19. So if I am receiving a set of routes, like this router is receiving a set of routes, and those routes, some of those routes have the metric value of 19 and the tag value of 200 or 2000, then they are going to be blocked. If the metric is matching but the tag is not matching, then it will not be filtered. If the tag is matching, metric is not matching, then also they will not be filtered. Both of the criteria must match. Like the route should have the metric value 19 and the tag either 200 or 2000. So we can say this, and here it is and here it is or. That means metric this and the tag this or this. Like this is how, if a route has both like metric value of 19 and the tag value of 200 or 2000, then only the prefix is going to be considered as matched and it will be blocked. So do I have any such prefix? Should I be route OSPF? Do I have any such prefix? You will notice that yes, you do have some prefixes that match with that criteria. You can notice here that you are no longer receiving 120 prefixes, because these 120 prefixes, 120 range that we have, this 120 range actually has the metric value of 19 and the tag value of 200. Show route map. As per this route map statement, the prefix must have the metric value 19 and the tag either 200 or 2000, then only it will be considered as matched and then it will be blocked. On these 130 subnets, we do have the tag value of 2000, but their metric value is not 19. Their metric value is 20. That's why they are not getting blocked. So the prefix must pass with both of the criteria so that it can be considered as match, and then either it will be denied or it will be permitted. So if I had said like route map ABCD, if I said like deny 10, match, metric 20, it means now I have added two statements. I have added two metric and I have added two tag, which means like if a route has the metric value of 19 or 20 and the route tag value of 200 or 2000, then it will be considered as matched and as a result it will be denied. So now we have 120 prefixes, we have 130 prefixes. Like 120 prefixes have the metric value of 19, 130 prefixes have the metric value of 20, and these have the tag value of 200, these have the tag value of 2000. So both of the criteria are matching. As a result, do show IP route OSPF pipe include 120 and 130. Both the prefixes are now no longer available in the routing table. We can actually match it. We can match as many criteria as we want in a single statement. If you write down this in two different statements, it's a whole different story. For example, you say sequence number 10, deny metric 19, 20, and sequence number 20, deny, tag, 200 and 2000. If you write down these in two different statements, that a different concept. If you say sequence number 10, deny, metric 1920, sequence number 20, deny, tag this. So what will happen? First of all, the first statement will be looked up, and if the route has the metric value of 19 or 20, that will be blocked. All the routes that have the metric value of 19 and 20, they will be blocked. And if all the prefixes that do not have the metric value of 19 and 20, it will be they will be looked up in the next statement. As per the next statement, the tag, if you have the tag value 200 or 2000, it will also be blocked. And if the prefix is not having the tag value 200 or 2000, then it will go for the next statement, and then process will continue. So there is a difference between the statements. There is a difference when we apply the route map statements into two different sequences, or when we apply the route map statements in a single sequence. If we have written down the statements like that, this and this, both the criteria must match from the prefixes, then only the prefix is either going to be permitted or denied. But if we have defined this in two different statements, that this is sequence number 10 matching the metric, then we have the sequence number 20 matching the tag, then like first this will be checked, then this will be checked, then the other, and then so on. I can add like multiple criteria. I can say again, like here, I can say, like for example, route map. I can say route map A, B, C, D, deny, 10, match, interface. I can also say that interface 2/0. That means now I have added three criteria. I have said that all the prefixes that have the metric value of 19 or 20 and the tag value of 200 or 2000 and being received on the interface FA 2/0. Like till all the conditions are met, the prefixes are not going to be blocked. So do we have any such subnets? Do show IP route OSPF? In fact, yes. You can notice here that 120 prefixes are being received. 120 prefixes have the metric value of 19, have the tag value of 200, but they are not being received on the interface FA 2/0. That's why they did not get blocked. They are being received on the interface FA 0/0. That's why they are accepted. You can see here the interface. But these 130 prefixes, they got redistributed. They were received on router 3 FA 0/0, and they were also being received on the FA 2/0. When these prefixes get received on the FA 2/0, they have the metric value of 20, they have the tag value of 2000, and they are being received on the interface FA 2/0. That is why those 130 subnets got filtered. You can notice here. See, I am not receiving 130 prefixes on the interface FA 2/0. I am receiving those prefixes on FA 0/1. So, like I said, it is completely your choice. It is completely your choice. You can decide, you can define multiple criteria. You can define multiple criteria as per the requirement. You can decide to block the prefixes that have certain metric value, that have certain tag coming on a certain interface. All the criteria is completely up to you. It is completely up to you what criteria you choose to block the prefixes. No, it will not block. Since you have specified three criteria, all the three criteria must match. Otherwise, it will not block. Since you have specified three criteria, all the three criteria must match. Otherwise, it will not block. However, in these three criteria, we have defined multiple values. So either this or this, either this or this, either this or this, but three, all of them must match. Otherwise, it will not block. You have like n number of criteria. We have like a lot of criteria. Match. We have a lot of criteria here. For example, I could have specified the route type. I only want to block the prefixes that is external type, 1 or 2, whatever. In OSPF, we cannot apply the distribute list or these things in out direction, so it's all in direction. We have applied this route map in direction, so only in prefixes will match. Right? So if we applied it in EIGRP out direction, then when the prefixes are being sent out of that interface, then it will match that. But in OSPF, that is not possible. Right? So we can have like multiple criteria. Now this time I added one more criteria. I said that the prefix, if the prefix has the metric value of 19 or 20, and the metric type is E2, and the tag value is 200 or 2000, and being received on 2x0 or 0x1, then only it will be blocked. We could have specified these criteria individually, then it will match based on 111 criteria. But if we have specified multiple criteria all in the same statement, all these criteria must match for the prefix to be either filtered or allowed. Any doubts if you have, let me know. Any questions if you have, let me know. This is basic route map statement. Remember that this route map is doing the filtering. This route map is doing the filtering in the entire routing table. This route map is performing the route filtering in the entire routing table. Any doubt if you have, let me know. Anything you did not understand, let me know. Now, we don't want to perform the filtering in the entire routing table. I only wanted to block or permit the prefixes, not on the entire routing table, but only in certain part of the routing table. Yes.
Sir, we are using the route map. If we use the access list
That's
and
what
in
we
the
are
same,
talk about.
yeah, yes, sir.
That is what we are going to talk about now.
Okay, okay, sir.
So far, the route map statements that we have applied, it is going to filter, it is going to check the entire routing table and do the filtering based on the same. But maybe we don't want to perform the filtering in the entire routing table. I do not want to perform the filtering in the entire routing table. I just wanted to perform the filtering in 120 or 130 range, only in this range. Only in this range, 120 or 130 range. I only wanted to perform the filtering in this particular range. It is completely possible that in the route map statements, we can also define the range where we want to perform the filtering. We can also define the range where we want to perform the filtering. Not necessarily that you need to perform the filtering in the entire routing table. We can say that don't perform the filtering in the entire routing table. Do one thing, perform the filtering only for 120 prefixes and perform the filtering only for 130 prefixes. Something like that. I can define the range. I can define the range in which we want to perform the filtering. Right? Okay. Now, to do that, first of all, what we need to do here, what we need to do, we need to configure either an access list or prefix list. Basically, what I'm trying to say is that it is possible to also call the access list or prefix list in this statement. It is also possible to use the access list or prefix list in the route map statement. Okay, how? Let's keep it simple first of all. I want to block all the prefixes of 120 range. Let's keep it simple that I want to block all the prefixes of 120 range, or maybe I want to block all the prefixes of 130 range, whatever. I want to block all these prefixes of this range. Okay. And this time I am going to use I'm not going to use access list or the prefix list directly. This time I am going to use the route map statement for the same. I am going to use this time the route map statement for the same. I want to do the filtering, and I am going to do the filtering based on the route map. Okay. So I am going to create an ACL. First of all, let's try to call the ACL in the route map. Remember that I am not going to apply this access list directly in the route map. Directly in the distribute list. No, I am not going to apply this access control list directly in the distribute list. I am not going to do that. I will go on this router 3. First of all, I am going to configure an access control list that matches our desired prefixes. What prefixes? 120.1.0.0 to 120.1.7.255. Create an access control list that matches your desired prefixes. So I'm going to write down the statement: access list 1 permit 120.1.0.0 0.0.7.255. This ACL statement is going to match all the prefixes in 120.1 range. And then I'm going to create a route map, whatever name of the route map. Then I'm going to say deny and match IP address, and match IP address here we need to specify the ACL. So ACL number 1 command is match IP address, either standard, extended, named, doesn't matter. Match IP address number 1 and permit everything else. What does this mean? We have configured a route map statement. This time this route map statement that we have configured, this is going to perform the filtering based on the access control list. So what does this statement mean? This statement means all the prefixes that match in the ACL 1, I am going to block them. This statement means, listen carefully, all the prefixes that gets matched in the ACL 1, I am going to block them. All the statements that match in the ACL 1, I am going to block them. And all the prefixes that do not match with the ACL 1, I am going to look up the next statement for the same. And as per the next statement, rest of the prefixes are going to be permitted. All the prefixes that match with the ACL 1, I am going to block them. All the prefixes, again, that match with the ACL number 1, I am going to block them. Now the question is, what prefixes are matching with the ACL number 1? If you remember from your ACL studies, like whenever you have covered the access control list in CCNA, CCNP, whenever, in fact, we have also covered the access control list a little bit. Remember that in access control list, we can have permit and the deny both of these statements. If you remember, in the access control list, we have permit and deny both of these statements. If a route is permitted, then it will be considered as match. And if the route is denied, it will be considered as don't match. Remember, when we apply the access control list in the route map, always remember, always keep in mind, that's why I am repeating it again and again. Always remember, when we apply the route map to perform the route filtering, and inside that route map, we have used an access control list to perform the matching. Always remember, ACL, access control list, anything that is matching in the ACL, route map can take action based on that only. Route map will take action only on the things that have matched in the ACL. In short, all the things that we have permitted in the ACL, only based on those, this route map is going to take action. Route map is not going to look up any statement that we have configured with the deny statement in the ACL. We have configured an access control list. That access control list has permit and deny both of this statement. Route map is not even going to look up the deny statement. It is only going to find out what things match from that ACL. And by what thing match from that ACL, what do we mean by what thing match on that ACL? Means that whatever we have permitted, whatever things we have permitted, whatever statements, whatever networks we have permitted, whatever statements we have permitted here, there, it is going to actually, only the things that we have permitted, remember, only the things that we have permitted, only the prefixes we have permitted, only the prefixes that we have permitted, ACL is going to take action based on the same. Your access control list can have a mix of permit and deny statement. Route map is not even going to look up. Route map is not even going to look up the deny statement. Basically, route map takes action based on everything that we have permitted in the ACL. Do not create any such concept that in ACL permit, route map deny, then deny, permit, deny. There is no such concept. This is an access control list. Find out whatever things we have permitted in that ACL, whatever gets matched from this ACL. An access control list can have both permit and deny statement. I do not care. Route map does not care. What is the permit? What is the match? What is the outcome of this ACL? What things will match from this access control list? What things will match from this access control list? Basically, whatever we have permitted in the access control list, route map is going to take action based on the same. So, what have we permitted on this ACL number 1? So, do show IP access list number 1. In the ACL number 1, we have permitted all the 120 statements. Yes, Navjot, that is correct. In the access control list, in the ACL, whatever statements are with the permit keyword, that is what route map is going to consider. So as per this access control list number 1, what is permitted? All the prefixes from 120.1.1.0 to 120.1.7.255, all these prefixes are permitted. Permitted basically means match. So this ACL, outcome of this ACL, what is going to match in this ACL? All the 120 statements are going to match in that ACL. And after these prefixes get matched, what the route map is going to do? Route map is going to block all those prefixes. So now if we apply that route map, router OSPF, distribute list, route map, name of the route map, CUSTOM, in. So now you can see do show IP route OSPF, pipe include 120. Prefixes are not there, but if you say 130, these prefixes are still there. You can consider it like that, if in the access control list the prefix is denied, that means route map is not going to take any action on that. That's as simple as it gets. Let me show you. See, access list 1, again, access list 1 deny 130.1. Do show IP route OSPF pipe include 130. Okay. So access list 1 deny 130.1.6.0.000. It is 30 now. So 30 is going to be like 3 to 50. 3 basically. Right. So 130 subnet. Then access list 1 maybe deny 130.1.1.0.000.255, and then access list 1 permit, let's say 130.1.4.0 and 0.0.0 slash 28, 29, 30, 31, 32, 16, 15, 15, right? Access list 1 permit, whatever, like, so this ACL, what I'm doing basically in this access control list, what I'm doing basically, I am writing down some statements that is a mix of permit and deny both. Check the ACL now, show IP access list. In this access control list number 1, in the ACL number 1, now I have a mix of both permit and deny statements. In this ACL number 1, now I have a mix of both permit and deny statements. Doesn't matter. Does not matter. This access control list, the outcome, what things will match as a result of this access control list? Everything that is permitted. So entire 120 range, then 130.1.4.0, and then entire 9.9 range. So the outcome of this access control list is only like what things are matching in this access control list. Only these 3 things are matching in this access control list. And as per the route map, whatever matches in the whatever matches in the ACL number 1, it is going to be blocked, and whatever does not match in the ACL number 1 is going to be permitted. So what should be the outcome of this route map statement now? The outcome of this route map statement is that you will not have to IP route OSPF, you will not have any 120 prefix, 130.1.4 subnet. You see, you don't have 130.1.4, you have everything else, and you do not have any 9.9 subnet. No matter if your access list has permit, deny, your access control list can have a mix of permit and deny statements, does not matter. Your ACL can have a mix of permit and deny statement, that will just not matter for the route map. Route map is only going to take action based on whatever we have permitted in the access control list. So find out what is permitted in the access control list, because the ACL will take action based on the same. Let me know if anything does not make sense. Yes, same concept for the prefix list as well. Similar concept for the prefix list. Anyways, now again, configure terminal, do show route map, delete this route map. Let me do one thing. Let me make it more complex. So route map, custom, deny 10, match IP address from the ACL 1, match tag 200, match route type maybe, match tag, match interface. We can give multiple criteria as well. Now, what does this mean? What does this mean? This means that this time I am not going to filter the entire routing table. This means only the prefixes that gets matched in the ACL number 1, only the prefixes that gets matched in the ACL number 1 and have the metric value of 19 or 20 and have the tag value of 200 will get blocked. So do check show IP route. First of all, what is matching in this access list number 1? What is matching in this access list number 1? 120 subnets, 130.1.4 and 9.9.9. Okay, that is fine. But not all the prefixes have the metric 19 or 20 or the tag value of 200. So if you check do show IP route OSPF, you can notice here, right here is your 9.9 subnets. They are matching in the ACL, but their metric value is not 20 or 19. Okay. Other than that, 130 is also there. 130.1.4 is also there. It is matching in the ACL, but and you can see here the metric value is also 20, but it does not have the tag value of 200. It has the tag value of 2000. But what about the 120 subnets? They match all the criteria. 120 subnets, they match with all the statements in the route map, do show route map. The 120 subnets are matching in the ACL, have the metric value of 19 and have the tag value of 200. That's why, like, those prefixes got filtered. Which will prefer in ACL, permit or deny? We have already discussed about that. Go through the video again. Already we have talked about that. Anything that is matching in the ACL will be taken in consideration with the route map. And by match, we mean permit. So permit. Go through the recording once it is done. It will give you a better idea. But just short answer, permit. It's like an AND operation. If all matches, then yeah. Not only denied, like if it was permit, it will permit. If it is denied, if it is like this, your like prefix must match with this statement, and this statement, then only it will be either permit or denied. And same thing applies for the prefix list as well. Same thing applies to the prefix list as well. Route map, custom, deny 10, match IP address from prefix list, whatever prefix list that you have configured. And then route map, custom, permit 20. So same statement, same things for the prefix list as well. Let's say, for example, I want to block all the prefixes in 120 and 130 range. IP, prefix list, Cisco, permit 120.1.0.0/16 less than greater than equal to 27 less than equal to 30. IP, prefix list, Cisco, permit 130.1.0.0/16 greater than equal to 29 and less than equal to 31, 32, whatever, 31, whatever. So I have configured a prefix list. Name of the prefix list is Cisco. This prefix list Cisco is going to perform the filtering in this range. So all the prefixes in this range that have the CIDR 27, 28, 29, 30. All the prefixes that are in this range with the CIDR value of 29, 30, 31. They are going to permit, means matched in this prefix list, and the route map is going to block them. So all the prefixes that get matched, in this prefix list Cisco, they will be denied, and rest will be permitted. So check it now. Do show IP route OSPF. You can see that you in 120 range, you are actually not having all the prefixes, and in 130 range, you also are not having all the prefixes. So similar concept, same concept is there. Here in the prefix list statement as well. Same concept, exactly the same things in the prefix list as well. No differences, same thing. Of course, you cannot specify access list, prefix list in the same statement. That is just not possible. But if you have matched the access list, you cannot call the prefix list. If you match the prefix list, you cannot call the access list in the statement number 10. So, but rest everything is exactly the same. You can match on one criteria, you can match on other criteria, completely up to you. You can have different criteria based on which you want to perform the matching. Okay. Now we can also perform like if I say, we can also for example, we are receiving all these prefixes, and maybe I want to block the prefixes with a certain metric range. That means, let's say, for example, I want to block all the prefixes that have the metric value from 20 to 100. I want to block all the prefixes. I want to block all the prefixes that have the metric range 20 to 100. That can also be done, but not directly, not simply, but that can be done. We can specify that route map, Cisco, then I10, match metric. Here, if you write down like 20, 100, it's not like 20 to 100. It's 20 and 100. Like if the route has the metric value of 20 and 100, it will be blocked. And there is no way that we can specify the range like that. So there is no such option. A dash or anything is not available. So if you want to match the range of the metric value, that is also possible. We are asked to match and block all the prefixes that have the metric value from 20 to 100. How can we do that? Okay, so metric range that we have to block is from 19 to 100. Okay, oh sorry, 20 to 100. 20 to 100. So first thing first, what we had to do, add both of, this is the lowest, this is the low value, this is the high value. Do one thing, add them and divide it by 2. Means find out the medium point for this. So it will be like 100 plus 20 equal to 120, divide by 2 is equal to 60. I'm going to call this M. M means medium, like in middle, the value is 60. So when we need to write down the range in the route map statement, we cannot write down the range directly. There is a very different way of writing down the range. We have to write down the range in this way. So now in this value 60, if you think about it, in this value 60, if I add 40, I will get the highest value, and if I subtract 40, then I will get the lowest value. So when we need to write down the range, the range is written in this format, plus minus format. So whatever range that you need to block, 20 to 100, find out the medium of the same, like M is equal to this plus this divided by 2, it is 60. Now in 60, how much should we add so I get this number, and how much should we subtract so I get this number? So if we need to find that out, just either from this 60 subtract the lowest value, you will get the result, or from the 100 to subtract this value, you will also get the result. Same, like anyway, you will get this number. So we have to write down this range in the format of M plus minus X, where M is the medium, like middle value of the metric range, and plus minus X. X is the, like, what should we add and subtract so I get this range. So I should write down like that: route map, Cisco, then I10, match metric, and 60, and plus minus what? Plus minus 40. So 60 plus minus 40. This is going to, call the range. So if you have to write down the range, you need to write down the range in metric range in the format of this plus minus. You need to write, if you need to write down the range is written in plus minus. So the value that is you have written here 60 plus 40 is going to give you the highest range that you want to filter, and minus 40 is going to give you the lower range that you want to filter. And now you can see do show IP route OSPF. In your routing table, you will have the routes. You will have the route, but in the routing table, you will not have any route that has a metric value of 20 to 100. You can find that out. You can check all the metric value. You don't have any metric value, any route with the metric value of 20 to 100. So it is also possible to find out, it is also possible to filter the prefixes based on the range. A lot of other concepts are there as well. Like you can find out the route map, Cisco, then I-10, and like a lot of other criteria are there to perform the matching, such as, for example, route type, internal, external, such as source protocol, OSPF, EIGRP, tag, metric. We can match the packet based on the length as well. If the length of the packet is this much, then I can use the route map statements, IP, IPv6, interface, other options are there as well. This is how we can perform this is how we can use the route map to perform the route filtering. And this is how we can use the route map in route redistribution. Right here on this router, I don't want to perform the filtering. I do not want to perform the filtering. Okay. I don't want to perform the filtering. I do not want to perform the route filtering. What I want actually, I want that this router number 8 must only redistribute 120 subnets and 9 subnets, nothing else. Okay, just go on router number 8, access list, permit 120 subnets, access list, permit 9 subnets, whatever it is. Then route map, ABCD, permit 10, match IP address from the access list 90. And router, RIP, redistribute OSPF, and then route map, name of the route map that we have configured here, ABCD. Selective redistribution is also possible. We can tell the router rip to not redistribute entire, like all the prefixes. I can tell the router rip to redistribute only and only these prefixes of OSPF. So I have configured an access list. In that access list, I have matched the desired prefixes. In this access control list, I have matched the desired prefixes. And then I have called them in the route map. So this route map statement ABCD is going to match and allow all the prefixes of the ACL 90. And now if you go on router number 13, you clear the routing table once and check it again, show IP route RIP. You will notice here, I think like, did we apply it properly? That's okay. These will get filtered actually. These will get filtered, but you will only have a 5-section router. Let's confirm that we do not have any other, like we don't have the route map with the name of ABCD created beforehand. So show route map ABCD. Okay. So the route map statement ABCD says that I'm going to match permit. I'm going to permit and allow all the prefixes in the ACL 90 and do like show IP access list 90. Oh, ACL 90 was already there actually, right? ACL 90 already created, ACL 90 was already created. So access list 90, I'm going to, ACL 90 was already created actually, I forgot. So ACL 90 was already created. So I have configured, I have deleted the ACL 90. Once I have deleted the access list 90, I have created the ACL 90 again. there I have matched my desired prefixes that I want to redistribute, and these prefixes are also matching in this route map called ABCD. So all the prefixes that match in the ACL 90, all the prefixes that match in the ACL 90 will match in this route map. As a result, only these prefixes are going to be redistributed. So once I clear the routing table, check it again, wait for 30 seconds, and you will notice that only those 120 and 9 subnets are going to be allowed here. We can actually control what prefixes we want to redistribute. We can match our desired prefixes in the route map, and then we can use that route map in the redistribution command. So as per this redistribution statement, redistribute all the OSPF prefixes into RIP, redistribute all the OSPF prefixes into RIP, but only those prefixes that match with the route map ABCD. And as per the route map ABCD, what prefixes will match? ACL 90 permit statements, ACL 90 permit prefixes are going to match. So once it is done, you should see all the prefixes that are coming in that range, they are matching here. They should not be there, but I think 9.9, 120, yeah, they should not be there. They will get filtered after some time, but these prefixes you can notice are available. So we can not only apply the route map to perform the route filtering, we can also apply the route map in redistribute state. We can add the tag, we can tag the metric value. We can not only see, so I can not only do show run pipe section router, pipe section route map. We can not only actually match, we can also say route map ABCD permit 10 match IP address from ACL 90. This means only and only redistribute the prefixes that match in the ACL 90 and set the tag value of 999. I can also use the set statement in the route map, and these are the things that we can set in the route map. Most of these set statements come under the BGP, a lot of things under BGP, but things such as tag, we can tag these prefixes with the tag value. Set metric value, we can also set the metric value, metric type, E1, E2, and all that we can do as well. So we can not only tell show route map ABCD. We can not only tell the router to redistribute only these prefixes, but we can also tell while you are doing the route redistribution, add this tag value as well. So all the prefixes that get redistributed, first of all, only selective prefixes will get redistributed, and the prefixes that get redistributed will also have the tag value. Like show IP route 120.1.0.1.0, you can check those prefixes will also have the tag value. Later on, you can do the filtering based on the same. So not only you can do match and block or match and permit the prefixes, you can also match and set the things such as tag and everything as well. This is also possible. These kind of things is also possible. We can also control like what prefixes are going to be redistributed, and we can control that these prefixes that get redistributed will have an additional tag value of 9.9.9.9. Yes.
Sir, the concept of route map is very clear, sir. But sir, one thing I just want to confirm, sir. Sometimes we use also export map. Is route map and export map the same, sir?
No. Export map is specifically for BGP.
BGP, okay.
See, eventually any map is going to use the route map. Like not always, but like in 90% cases, like anytime you hear the keyword map, mostly it will be a route map. Except for that policy map in quality of service. But in most of the situation, any map you will see export map, import map, this, that. All those things are again eventually going to use the route map in Excel. But the concept like of the export map, import map, inject map, this, that is specifically for BGP, MPLS and all those.
Okay, sir.
Yeah. So this is the second place where we can use the route map. Like we can use the route map in route filtering. We can use the route map in redistribution. Not only that, see, a lot of places we can use the route map. Go to router number 12. On router number 12, what I'm going to do? On router number 12, I have all these loopback interfaces. I am advertising all these loopback interfaces to router number 11. What I am going to do here, what I'm going to do here, that from router number 12, IP, summary address EIGRP, and I am going to summarize all these prefixes. Go to EIGRP classes to understand what is summary and all. So what I did actually here, instead of advertising the prefixes as it is, out of the interface FA 0/1, instead of advertising the prefixes as it is out of the interface FA 0/1, what I did a route summarization. IP summary address, EIGRP, and then the subnet. If I go to router number 11 now, I do not have the exact route, I just have a summary. Okay. So on router number 12, what I did actually, I did the route summarization. I did this route summarization. And because of this route summarization, router 12 is not advertising the 120 prefixes as it is advertising a summary. Suddenly I remembered that actually this subnet and this subnet, I suddenly remember that I have to advertise as it is. I suddenly remember that these two subnets I want to advertise as it is. This subnet and this subnet. I suddenly remember that these two subnets I want to advertise as it is. Rest, all the prefixes should be advertised in summary, but these two prefixes should be advertised as it is. Okay, no problem. Route map, you can create an access list. In that access list, you can match these two prefixes. Then you can create a route map. In the route map, call that ACL. Do it yourself. What I'm going to do, I'm going to create a summary. I'm going to create a route map. XYZ doesn't matter. Permit 10, match interface, loopback 3 and loopback 4. I can directly match the interface. So the IP address of that interface will get matched. If that doesn't work, configure the ACL and in that ACL match the prefixes. So what I did, I configured a route map named XYZ, permit 10, match interface, loopback 3 and loopback 4. Basically like IP address of the loopback 3 and loopback 4 interface will match here. And now what we have to do, interface FA 0/1, IP summary address EIGRP 100, 120.1.0.0 to 55.255.0.0. And right here we can apply this thing called the leak map. And eventually it is the route map itself. Route map can be used also as something called a leak map. This leak map basically means that I am telling this router number 12, that you need to actually, I am telling this router number 12 that you need to actually advertise these prefixes as it is. You advertise the summary, that is okay. You advertise the summary, but these two prefixes, you need to advertise as it is. I can leak certain prefixes along with the summary address as well. Unfortunately, that might not work. We match interface and those things will specifically like we use when we use the router, like redistribution and all those things. So I don't think like this is going to work properly. But anyway, let's cross check first. So if I go to router number 11 and if I check here, Yeah, that is not working. So what I need to do here, I can go on the router number 12. I can say like do show run interface loopback 3. I can say like access list, maybe 80, then match 120.1.3.0, 0.0.0. Whatever it is, 255, doesn't matter. And the access list 80, permit 120.1.4.0, 255, do show run pipe section, route map. And this route map statement, I'm going to delete and reconfigure. And this time I'm going to match IP address from the access list number 80. So that statement was not working, match interface was not working. So what I did, I configured an access list. In that ACL, I have matched my desired prefixes 120.1.3, 120.1.4. I have matched my desired prefixes in the ACL. I called it in the route map, and I applied that route map in the leak map statement. Yes.
So I think it is not working because interface address can be a different IP from different range, correct? So
no, that's not the condition. Like when we apply this route map in direction, out direction, then only it will be able to match the interface. Now we are not actually applying that route map to perform the filtering in either in or out direction. That's why it is not matching. We are applying this route map in a summarization, route summarization. We are not using this route map to perform the filtering on the interface loopback 0, loopback 1, loopback 2. So that's why it's not matching.
yeah, but it will work like this, like the range. Suppose the interface loopback interface IP is in 130 range, and you have mentioned that our range, which desired traffic is 120.1.0 range, and the loopback IP is in 130 range.
So it will not match. Matching the interface will not work. You have to write down the access list that matches the exact range, and then you can call it in the route map.
Okay.
So if you needed to match the range, then you need to match the range in the ACL or the prefix list, and then call it in the route map. Now, if you go to router number 11, let's see what happened. So now you can see that you are having a summary, and you are having those two subnets as it is. So the entire 120 range is being summarized, but these two prefixes are being advertised as it is. Leak map. I can leak certain prefixes. Match the prefixes that you want to leak in an access list. Match the desired prefixes that you want to leak in a prefix in the access list, prefix list, whatever, and then call it in the route map. And then apply this as a leak map on the specific interface from where you want to actually leak those prefixes. So route map can also be used in this manner. Route map can also be used as like something called a leak map here to leak certain prefixes out of the interface instead of advertising the prefixes in a summary format. This is also one use case of the route map. Okay, what else? Okay, let's go to router number 11 or router number 12 maybe. Remember that we have the option on router number 11, router number 12, that router EIGRP, we can configure this thing called EIGRP stub. We can configure stub configurations in EIGRP. We can use this EIGRP stub command here. So the point is that, again, remember from our EIGRP classes, that if I configure this router as the stub router, all the prefixes that it has learned, it will not advertise to the neighbor router. All the prefixes that it has learned will not advertise to the neighbor router. But I want it to advertise those prefixes. So you can go on router number 12. You can create an access list that matches your desired prefixes. Create a route map for the same. Whatever, doesn't matter. Permit 10, match access list 90. I can create an ACL to match my desired prefixes. I can call it in the route map, and then router EIGRP stub, and then here also we can reference the leak map. And eventually leak map is again going to be the route map. So in another way, what we just told this EIGRP router that you cannot be queried. You are stub. That means no one can query, but you are going to advertise the prefixes that you have learned to other router, that you have learned to the leak map. Basically means that I can also tell this router to advertise the prefixes that you have learned to the other router, in this format. Possible. Here also we can see the use case of the route map. In the leak map, we can see the use case of the route map as well. So route map, similar to this, route map can be used in quite a lot of places. Route map can be used in quite a lot of places. Route map can be used in the prefix list. Route map can be used in the in the route filtering. It can be used in redistribution. It can be used in the leak map. It can be used in the summarization. It can also be used in something called policy-based routing, which we will cover later on, not today. Policy-based routing, like we can also use the PBR. We can also configure the route map in the policy-based routing as well, right? So, which we are not going to talk about because we have already talked about the policy map right here on 6th number recording 25. Go through it. We have already talked about the policy-based routing right at this point. We can also use the route map in the policy-based routing. So, fine. So we can configure the route map in variety of places, not only for the route redistribution. We can also use the route map to set the tag while doing the redistribution. We can use it for route filtering. Like in a lot of places, we can use the route map. So in short, the route map is a set of permit and deny statement. Again, in the route map, we can have permit or deny statement. We can call the access list. We can match on different criteria. We can match on the criteria that your ACL and prefix list cannot match simply. Criteria such as metric, criteria such as, for example, metric range, criteria such as, for example, tag, criteria such as, for example, interface, tag, and all those things. So your route map can actually match on the criteria that your typical access list or prefix list cannot, in fact, match. So the point remains the same. Like we can use, this is it, this is done. These are all the criteria, these are all the things that we can use from the route filtering point of view. So route map is now going to be heavily used in the border gateway protocol later on. So I would advise you to cover the route map properly, how to configure the access list in the route map, how to use the prefix list in the route map, how to use both of them. So go through all these, like, testing that you can do. And because when we start the border gateway protocol, when we start the BGP, maybe from after once the theory part is done, you will see the use cases of the route map right away. So this is all that we need to know from the route filtering point of view. This topic concludes like how to perform the route filtering on any routing protocol. We can do the route filtering on EIGRP. We can do the route filtering on OSPF. We can also do the route filtering for static routing by setting the AD value to 255 and so. Same concepts will be applicable for the BGP. So we will not talk about this in BGP, just to make it clear. In the BGP, when we reach out to the point of route filtering, I will just use the access list, prefix list, route map to show you how the filtering is done. We will talk about additional concepts of route filtering that we have in the border gateway protocol, but we are not going to talk about these things again. The concept remains the same. So it will be now completely on you how much practice you do for the same. Okay, so this is done. This right here is done.